Yeah, hi. Morning, everyone. We will start at 9:45 sharp. So hi. Good morning, everyone. Let us start the session now. Okay. So I think like two people are not able to join today, so which they have mentioned. So I hope my screen is visible, right? I have shared my screen. Can someone please confirm? Okay. Thanks so much. So last week, like we have completed the Azure application service, and we had started with something called as Azure
Hello.
networking. Yeah, hello.
Good morning, sir. Last week record is not shared, class record.
Yeah, so I mean, I have asked Kunal and Meena to, I mean,
Okay,
the new skill learning team to share. So they said that, I mean, they will share it by end of the day.
sure, okay, sir.
Yeah,
Because
so
last week I'm not attending the Sunday. That's why.
okay, sure. So networking is not at, I mean, it's not covered fully. So I'll recap what we have done, and then
Okay, sir.
we will proceed with it.
Sure, okay, sir.
So yeah, so the people who are present last week, we have spoke about IP address as well. But what I'll do is that I'll repeat that again because like we have studied what is a classful IP address, and today we are going to learn about the classless IP address. I know it's been a week, so it's better that I'll repeat the IP address I mean session again, and we can proceed. So recapping like what we have done. So we have discussed what exactly is a Azure vNetwork, the virtual network, right? So I mean, if you talk about the networking. So networking is nothing but the communication in very generic terms. So if you are sending a letter to your friend or family, or if you are sending a WhatsApp message, or if you are, sending an email for that purpose, it is nothing but communication. So every communication needs a recipient address, right? So if you want to send a letter, then you will be needing the postal address. For the WhatsApp text, you will be needing the phone number, and for the email, you would be needing the email ID. That is obvious, right? So that is called as the address. So, and after that, like we spoke about like how in our the home, the typical network structure is, just to understand how the routing and all will work. And we discussed about something called as the switch. So in our on-premises environment, or for the office environment and all, so we have something called as switch. From the switch, we will, the example for switch is Cisco switch. Usually it's a 48 port switch, and the network communication or the LAN cable would come from switch to your laptop, and the switch is have dedicated 4 port, from where we can take a uplink, and we can connect it to either the firewall device or the gateway. So in short, that is what we studied about the switch. So as of now, the switch, it is not exactly required, because we do not have the concept of switch in Azure. So the alternative for that, or what we have in Azure, or the backbone of Azure, is nothing but something called as the virtual network, or the VNet. So the VNet, it is responsible for happening this network communication between your Azure resources. When I say Azure resources, it could be the Azure VMs, or the different Azure resources. And for every network communication, we also studied that like we need IP addressing, or Internet Protocol address. And in the IP, we spoke basics about IP. So we have 2 types of IP. One is a private IP, and second is a public IP. In private IP, it is nothing but it's for your intranet purpose. When I say intranet, the people within the same organization or within the same network, they can access it, and it is not exposed to internet. Okay, so that's the private IP, and public IP is something which is accessible by the user all across the world. Using their browser or something. So that is, we have discussed that it's a public IP address. And in IP, we also studied about the IPv4 structure. So IPv4, it is a decimal representation. So this is a decimal representation. First of all, like we spoke that it's having 4 octet, right? So when I say octet, it is nothing but 8 digit. So usually, one example is 10.0.0.0, or maybe 1. Okay, so this is typically how the IPv4 addressing will look like. So when I say for the 4 octet, this is the first octet, this is the second, third, and the fourth. So when I say octet, it is nothing but the 8-bit representation. So if I take the simple example of 1, 0, 0, and 1, so how this is represented in binary. So as of now, like this is a decimal representation. When I say decimal representation, it is the 0 to 9 to the base 10, right? So this decimal number is something which we use in our day-to-day life. You all aware of. But usually your system or your laptop or VM, it is not able to understand this decimal system. So we have to do the conversion to something called as the binary system. When I say binary, we have only 2 digits, as you might be knowing, 1 and 0. The maximum value is 1 and the minimum value is 0 to the base 2. So when I can represent this 1 in the binary as 70 followed by 1. Then for 0, we will put 0 itself. Again, it is same, and again. So this is how your 1.1.10001 IP address will look like. Okay. So we have another IP which is called as the IPv6. So even though we have IPv6, it came just because the unavailability of the IPv4. When I say the unavailability, it means that in recent time, the number of devices which are connected to the internet, or the number of internet users, has been significantly increased. And it has happened that there is a shortage of IP addresses. So in order to overcome that, we have something called as the IPv6 addressing. But still, for all communication purposes and all, we still use IPv4 itself. So just to know how the IPv6 is represented, it is a hexadecimal. So it has 0 to 9, comma, A to F. So that is how your IPv6 look like, and base to the power 16. So it's a hexadecimal. So if I open my CMD, it's IP config. So this is my wireless LAN adapter. So this is my IPv4 address, whereas this number you can see it here, right? So this is the representation of IPv6. So as far as this course or module is concerned and the Azure is concerned, we do not need to worry much about IPv6. So we'll be concentrating on IPv4 itself. Then after that, we studied about IPv4, right? So, or the IP addressing in detail. So I'll repeat that session again, and we will proceed to the next the topics which we have in this module, which is the module 7. So in Azure or for the networking concept, you know that address is something which is very important. And when I say address in case of the Azure or your networking concept, the address which we usually have is nothing but the IP addresses or the Internet Protocol address. So yeah, just to repeat, I mean, we have two types of IP address. We have just discussed, which is IPv4 and IPv6, right? So that is one category which I have discussed already, the binary representation and so on, right? Yeah, and talking about the IPv4 addressing. So we have seen that the maximum limit of IPv4, it is limited to 255.255.255.255. So this is a minimum, I mean, this is a maximum IP address, which is limited, and we cannot go beyond that. Now you might be now you might be thinking, what is the reason for that, right? So we cannot be having something like, for example, let us say 400.700.700.200, for example. So that is not possible because, like I told you, when we represent any of our IPv4 addressing, I mean, we use two types of formatting. The first, the format is the decimal number system where we write it in the numbers, which is 255 to 255 to 255 to 255, right? And in order for the system to understand that, we have something called as binary representation. So now, you know that in binary, we have 8 digits, right? When I say the binary, I mean the octet in IPv4, each octet, it is having 8 digits. So if I write 111, 4, 5, 6, 7, 8. So this can be written like that. I'll explain you. And so on, right? All the 4 octets can be written like that. Now, the first digit you can see here in this binary representation, it is 2 to the power 0. Second one is a 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, and the 8-bit or the 8th bit, it is a 2 to the power 7. Now, if you add everything, which is 2 to the power 0 plus 2 to the power 1, and so on till 2 to the power 7, if you add that, I mean, you can do it now also. I mean, you can use a calculator and you can do that. The sum which we get is a 255. So that's the reason that IP address cannot go beyond 255. Now, so that's the reason that we have this limitation. So you can do this conversion. I mean, you can do this conversion by yourself. I mean, if I write 192.0.0.0.1, so even it has the representation in the binary. So you have to decide like you have to place ones in such a way that the total sum of this octet should result in 192. You can try that. It will come to some digit. Okay. So that is what the binary representation. Now, after that, like we studied something important. Now, just remember, we are talking about the classful IP address as of now. So we have categorized this IPv4 into 5 different classes, which is class A. You might be aware that the class B, class C, class B, and class E, right? So we have seen that, but let me repeat that once again because that is needed for today's session. So when I say class A, so what exactly it means? So when I say class A, we have the range of IP starting from 1.0.0.0 till 127.255.255.255.255. Just 1 minute. Okay, so this is how the class is represented. And then again, like we have after 127, I have 255, 255, 255. Just because like this is the maximum I can have, right? So after this particular digit, that is after this particular octet, 127, 155, 255, 255, 255, we will be directly having the 128. So the class B, it will start from 128 dot 0.0 till we have something like 191.255.255.255. Okay, so that is the class B IP address. When I say class C, it will start from 192.0.0.0 to 223.255.255.255. Okay. So basically, I mean, all in Azure or like anywhere in your networking concept. So we will be having the IP address which belongs to class either A, B, or C. Okay. Now you might be thinking like we also have class D and class E, right? Because the like I told you, the class C it will terminate at 223.255.255.255. We still have the digits remaining from 224 to the 255. So just to give for your information, the class D, it will class D and class E, they are reserved IP addresses or the class. When I say that, I mean they are reserved for this special purpose. And as the common the internet users or even the corporate employees, we cannot use this because they have this special purpose for that. The first is I mean, they are reserved for the multicast as well as the streaming, online gaming, etc. Okay, and the class E, it is reserved for the research purpose. Research purpose means like your scientific research purposes and all. For those reasons, class D, the class E is reserved. So that's the reason that class D and class E will not be using that. Okay, so even in our module, we will be concentrating on all these 3 specific classes. So we have, I mean, we had covered this as last week, if you remember. I mean, the last week. Uh, yeah. So okay. So this is about yeah. So this is about the classification of the IPv4 address into the different classes. But like I told you, your laptop or your machine or even your virtual machines, they cannot tell. I mean, if I give a particular IP address, for example, let us say that if I we'll take the same example, 1.0.0.0, and if I input this IP address to your system, so it will not be able to understand to which IP class it will belong, right? I mean, you cannot go and tell your laptop that, okay, since it's a 1.0.0, this belongs to the class A. No, you cannot do that. For that, we should have, there should be some additional factors which are present, and it is the one which makes this differentiation of this the IP address to class A, class B, and class C for your system to understand. The point here is nothing but the classification is completely based on something called as the network bit and the host bit. Host bit. I hope you remember we discussed that, but that is fine. I'll repeat that again. Okay. So when I say the network bit and the host bit for the class A and class B, class C for that matter, the network bit and the host bit portion, it will vary. Okay, so we know totally that like here, totally we have 32-bit addressing schemes which are available for us. So now this out of 32 bits, how many network bits are reserved for network and host? That is what we need to understand. So let me draw a simple diagram and let me explain you. So let us say that this is your VNet, and let us take the same example of 1.0.0.0. Okay. So this VNet is connected to your different host or the machines. Okay, so let me say that this is the first machine, this is the second VM, and this is the third VM. Right? So first of all, let us understand what exactly is a network bit and what exactly is a host bit. So we discussed about the networking structure, in the last class. And I explained you, right, that we have a switch, and to that we have our laptops or our desktop, and like for that matter, any devices, they are connected to that, etc. And if you remember, while discussing upon the networking concept, we studied that the VNet has the four different components, which is the address space, the region, the subnet, and the subscription, if you remember. And the first topic which we covered is nothing but the address space. When I say address space, it is nothing but the range of the IP addresses which can be assigned to your VNet or the virtual network. So in generic on your like on-premises setup or for your office setup, so we provide this IP address to your VNet or to your switch. So similarly, the address space or the range of IP addresses, they are given or they are associated to your VNet. For example, in this case, let me say that like I have given the range as the 1.0.0.0. This is not the complete the format. We have something called as the /16 or /24, which we will see shortly. Okay. So let us say that this is the IP address range which I have provided for this particular address. Setup, or I can say that it's a address space. So this is what we call as the network or the network ID. So this particular ID, which is or IP 1000/16. So this will become your the network address. Now you can see here the different virtual machines, right? The virtual machine 1, 2, and 3. Now they are connected to your VNet, which is having the address space or the network ID as 1000, and they will be having they will derive their respective IP addresses from this network ID itself. For example, this might be 1001, this might be 1002, and this might be 1003. Right? So these hosts which are connected to your VNet or this particular setup, these are called as the host or the host network. Okay, so now we have understood what exactly is a network, which is nothing but the address space which has been specified or given to here. And the host is nothing but the devices or the network devices which are connected to your the virtual machine. Sorry, the VNet. Okay, now let me explain how the class A, class B, and class C network bit and the host portion works. Okay. So when I say class A, I'm talking about the class full category. So when I say the class A, we have one network portion and one three host portion. Okay. Remember when I say class A, it's a one network and the three host bit. When I say class B, we have two network bit and two host bit. Now you might be understand. Now you might be thinking why the two component. I told you we have the IP addresses in the 4-octet format, right? For example, 1.0.0.0. So this is the class A. As of now, you can understand that. So in class A, this particular number, I mean, this first octet, this is a network bit, and these three bits, which is 0.0.0, these are the host bit. In class B, we have the two network portion. I mean, the first two octet, they will be the network bit, and the last two would be the host. Whereas in class C, the three portions would be for network and one portion for host. Now, let me take one example of class C IP address and let me explain you. So, class C, it will start from 192, right? So let me take the example at 192.0.0.0, which is nothing but your class C. So we know in class C, we have, I mean, considering this architecture, we have three network bit and one host bit, right? So you know that like the first three octet, they are the network, and the last octet, which is the host. So the point here, I mean, when I say that, the point here is that if you take the class C IP address, while giving the IP address to the particular host, no, this is the network ID or the network bit, okay? I mean, the network ID or the host, the address space. So when I take this class C IP address and provide the IP addresses to your host, when I say host, right? You now know that they are nothing but your virtual machines or any devices. So when we give the IP address to the host, you can make change only on the host bit. So remember that. So if I told you like we have the VNet setup and this is the IP address associated with that. Okay, this is the address space. And let us say that you have the two machines connected. So when I say that like this particular host, it will derive the IP address from this network space. So the three portions, which is the 192.0.0, these are the network bit, right? In the class, you can see that. So they are reserved and they cannot be changed at any, I mean, they cannot be changed at all. So it will remain as 192.0.0.1, then the 192.0.0.2. So this is how the IP address can be given. That is, I mean to say that only the last bit, which we have here, the fourth bit, which is the host bit, only this can be changed. So the changing of 190, you cannot put like 192.1. If this is the range IP address space, you cannot do like 192.1.1.0. So that is not possible because the network bits cannot be changed. They are reserved and they cannot be changed. Only the host address, they can be changed. And yeah, that is what, I mean, you have to remember that, okay? And now you might be thinking like how many host addresses I can give, right? So we have the total number of IP addresses which are available are nothing but 2 to the power 8 because we have only the last bit, right? So when I say the last bit or the last octet, which is nothing but we have only the 8 bit, they can be changed. So in decimal representation, when we convert that, it is the 2 because base 2. When I say 2 to the power 8, it is nothing but 256 IP addresses. This can be assigned to host. But out of this 256, the first IP, which is 192.0.0.0, this is already reserved as your network ID, or it is assigned to your VNet, right? So that one IP is gone from here. So we have 255 available IP addresses which can be assigned to host. Now, but always remember that the last IP address, let me type that, which is 192.255.255.255. This is always reserved for the broadcast purpose. So this IP address is also gone now. So you are left with the 254 total IP addresses which are available. So always remember, whenever someone asks you that, okay, for the class C, how many IP addresses are available? So you have to do 2 to the power 8 because we can change only the host port. So the 2 to the power 8 is nothing but 256. One IP is reserved for network and one IP is reserved for broadcast. So subtracting that two, or we will get 254. So the 254 are the total IP addresses that are reserved. We have discussed that as well, right? Now let us say, okay. Now let us say that you have 250 machines, for example. Okay, now you know that in class C, just to repeat, in class A, class B, class C, we have something called as a network bit and a host bit. The class A has one network bit and three hosts. Class B has two network, two hosts, and class C has three network and one host. Right? And when I talk about the class C IP address, the total number of available addresses are nothing but 2 to the power 8, and removing the two reserved IP addresses, which is nothing but 254 total IP addresses available. Okay. Now, let us say that you get a requirement, or like you will be having a setup where you will be having the 250 virtual machines or the 250 laptops. Now, for these 250 machines, you can start assigning the IP address from 192.0.0.1 and end up with 192.255.255.250, right? No problem for that. You have created a flat network. When I say the flat network, it's a LAN network, which can communicate, and these virtual machines, for example, this example, let us take as the VMs only, VM itself. So these VMs, they can communicate with each other without any problem. Okay. Point here. So let us say that this is my VNet, and the network ID is 192.0.0.0. And let us say that we have four VMs assigned here. The first VM, second VM, third VM, and the fourth VM. So let us say that, I mean, these are the like 250 VMs here. These are attached to this particular VNet, and this is possible because like we have the 254 IP addresses available, 250, which we can easily associate that to the respective IP, I mean, to the virtual machines, and we can enable the communication between them. Now, instead of going to this method, I mean, instead of going for the flat network, so let us say that for these two particular VM, I mean, let me group them here. So let me group these two VMs, okay? So this is the first set of VM, and this is the second set of VM. So let us say that for the first set of the VM, you used 192.0.0.0 series, and for the second set, you decided to go for type. I can go it here. Let me navigate dot 0.1.0. Okay, so even I can do like that. I mean, I can set up the two different the setup, and I'll start as giving the IP to them. So let us say that this first VM, this will be having 192.0.0.1, and this is 192.0.0.2. Whereas this VM, it will be having 192.0.1.1 and 192.0.1.1, because I mean, as of now, like these are the IP, these are the address space, okay? So let us say that, I mean, we will do like that. So what exactly happened? The VMs within this first set, they can communicate with each other without any problem. And the second also, they can communicate with each other without any problem. But these two segregated, isolated groups, can they communicate with each other? No, they cannot, because as you can see here, this we have 3N and 1H portion. Here also we have 3N and 1H portion. And for the communication to happen, the network bit, they should be same. You can see the first octet, it is not a problem. It is a 192 on both the side. Second octet is a 0. But the third octet, here it is 0 and here it is 1, right? So that's the reason that, I mean, they cannot communicate with each other by default. There are some other routing mechanism which we will study shortly. But as of now, considering this setup, I mean, without any kind of routing and all, the first set of VMs, they won't be able to connect to the second set of VM and vice versa, because the network has been split and there is a change in the third octet, which is the third network portion. Okay, so this is the one scenario. I'll tell you why exactly it is required. Now, let us say that you have, instead of the 250 VMs, let us say that you have 300 virtual machines. And do you think that the class C IP address is sufficient to create a flat network right now? If I have the 300 virtual machines, so the requirement is that like I should be having 300 virtual machines to be connected to my VNet, which belongs to class C. Can anyone tell me, is that possible? I mean, considering the flat, when I say the flat network, like you're directly associating your virtual machine to your VNet. So can someone tell me, is it possible that we can connect 300 virtual machine to the class C with a flat network structure? Yeah, Santosh, can you tell me how, I mean, considering the flat network structure without doing any kind of subnetting?
Subnetting, we can't.
Yeah, exactly. So
300 machines, it will automatically changing that zero means one the update and it will change, but subdate is not there, means we can't.
yeah, exactly. Yeah, I'll come to the subnet point later. So when I say the flat network, it is the direct network as it is. Okay, so it's not, we are not subnetting that. So we'll study the subnetting as well, which is essential. Okay, so the flat network, it is not possible, like I told you. So the maximum number is 254. The 254 IP addresses which are available, but you have here the 300, which means approximately 46 virtual machines. They won't be having any kind of IP addresses. Now there is one more method. What you can do is that okay, I mean, talking about the classful IP address again, not the class. So I'll tell you why I'm stressing this point. So considering the class C IP address, it is not possible. And if your requirement is that, okay, I do not want to segregate my network, or I do not want to split my network or subnet my network, I just need a flat network. Then one possible solution is that instead of using the class C, you can go for class B, right? Because in class B, the structure is 2N and 2H. So if I want to calculate how many IP addresses are available, it is 2 to the power, here 8-bit and here 8-bit. 8 plus 8 is 16, 2 to the power 16, which will come approximately around 65,000 available IP addresses. If you go for class B or class A, then obviously you can create a flat network with that. But you will see that you have just 300 network, I mean 300 virtual machine, that's all. So in future also, you might be having more maximum like 200 to 300 VMs, which could be added to your setup. So which means, okay, even, I mean, if I take any kind of rough approximation, let us say that at any future point of time, like we'll be having 1,000 virtual machines, but the available IP address which we have is a 65,000, right? Approximately. So which means that 64,000 IP addresses, they are being wasted for no reason. So that is not a recommended way in classful. I mean, when I talking about the classroom. So that's the reason that what we can do is that we have to I mean, segregate them in this manner. We have to, let us say that the first IP address, like, I mean, we will subnet them or we will split them. The first range would be 192.0.0. The second would be 192.0.1. Here, as you know, we have 254 IP addresses and we have 254 IP addresses. You can do that, right? So your networking, it will become possible. But the problem here is that between these two, by default, if you want to enable communication between these two, by default, that is not possible. So that's the reason that you have to associate something called as a router. So as you can see here on the left-hand side, I have one segregation or one pool. In the second right-hand side, I have one pool. So let us say that, I mean, we have 250 virtual machines here and maybe like 200 virtual machines here. Okay, so what I'll do is that I will,
Hello, sir.
yeah, hello.
So one doubt.
Yeah,
For
sure.
example, two companies is there. Two companies are same like 10.10 IP.
Your voice is breaking,
Means
Santosh.
same IP is there.
Hello?
Now, hello,
Yeah, Santosh.
can you hear me?
Yeah, yeah. I mean, in between your voice is breaking, Santosh.
Can you? 1 minute, sir.
Yeah, sure. I'll hold it.
Yeah, can you let me say now?
It's better. Yeah. Tell me, Santosh.
For example, two companies is there. Two companies is IP is the same, means the same digit, the same subnet like that is there.
Okay.
If, for example, if this company will communicate with this another company, it will happen or not happen. Means I'm asking how it
Yeah.
is.
Let me explain. So usually,
Same
Santosh,
IP,
yeah.
but different location.
Yeah. So usually, Santosh, I mean, the companies will be when they're having these IP addresses, these are usually the private IP addresses. Okay. So when I say the private IP addresses, these are I mean meant only for that company. Okay. So let us say that like we have the company A and company B. Company A might be having the same IP address for its virtual machine. For example, 10.0.0.1. Okay. The company B, there is a high, I mean, there not there is a high. Obviously, the company B, it will also be having the same IP address, but that is internal to use. So that's not a public IP address. So there will not be any kind of conflict is happening because company A infrastructure is totally different and companies B infrastructure is different. And since these are private IP
Yeah.
addresses, the communication will not happen between them. So that's the reason that there will not be any conflict and it is possible. But if you say that about the public IP addresses, then no, the public IP address that cannot be seen, right? I mean, if I consider, for
Yeah.
example, yeah, if I have facebook.com and for the Facebook, let us say that the public IP address associated it is 20.50.50.50, just an example. So no, Santosh, if you want to set up your own website, you cannot use this public IP address, right? Because that is already being used by
Yes,
Facebook.
sir.
So that's the reason that for the public IP,
Yeah.
you cannot have the conflict. And for the private IP, since it is an isolated environment, you can have the same IP address. Okay, but let us say that the company which we are talking about, so let us say that they are partner company. When I say the partner company, like let us say the YouTube and the Instagram, they are, yeah, I mean, any companies like which work together or which have some dependencies. And let us say that the company A is actually connected to the company B. Okay, so that's a requirement because they both come under the same organization and they'll be selling different products with a different branding name, but they belong to the same company, right? For example, Google Images or the Google News. So they belong to the Alphabet. It's a parent company for Google, right? So if you consider that case, then obviously the communication should happen. Now, in that case, if you have in company A, let us say that if you have 10.0.0.1, and in company B, if you assign the same IP address 10.0.0.1, then for sure conflict will happen. And in that case, you're not allowed to use the same IP address. Then the IP address should be unique. So is that clear, Santosh? The two different
Okay.
scenarios.
Yes,
So
sir.
if the companies
Yes,
are
sir.
connected together, if they want to communicate together, so that is possible. You have something called as the express route or VNet to VNet routing, etc., using the gateway device, which we'll study. So that's a different thing. I mean, if they want to communicate with each other, then having the same private IP, that is not allowed. So that will create a conflict. But if they are isolated environments, I mean to say that there is no communication between them, then it is possible. Okay. So is that clear to you?
Sir. Yes, sir. Clear, sir.
Okay, thank you. Okay, so now in this particular scenario, so the like I told you, the direct communication, it is not possible. Okay, so what we have to do is that we have to take something called as a device which is known as the router. So what I'll do is that I'll take uplink here and I'll connect to here, and one more I will take it here and connect to here. And in the router side, like you will be instructing the routing. For example, like in the router, we have different protocols like static protocol, RAP protocol, MPLS protocol, etc. So this router, with the help of this routing protocol, what it will do is that it will take the package, it will take the packets from here. Let us say that this is one packet here. It will take accept the packet here, and with the help of this router, this packet will be moving to here, and or vice versa, or in this two-way communication. So this is the power of router. So even if you have this kind of segregated network, and like usually in your corporate environment, so it is possible. I mean, usually we will be having this setup where you will be subnetting your the network, and you will be using minute-to-minute peering or using the router, and you can enable the communication. So till now, till here, we have covered last week. So so I just wanted to refresh the content here because I mean, moving forward, this was required. Now, I'll tell you one simple questions. Okay, so let me take the IP v6 and class C IP address. Let us say 192.10.20 sorry 10.11 and 192.168.10.250. So let us say that we have two virtual machines here. The virtual machine one is having this first IP address, and virtual machine 2 is having the second IP address, which is .250. So can everyone confirm in chat if these two virtual machines can communicate with each other? Remember, recall the concept of network bit and host bit. And this is a class C IP address. So I would request everyone to confirm in chat if these two virtual machines can communicate.
Yes, they can communicate.
Yeah, they can communicate just because like the network portions are same. Yes, yes, that is correct. Network bits are same, right? And let me take one more example of okay, maybe let me take the class E. So I'll write 10.10. 1.0 and 10.10.2.0. Now, what is the what will happen here? The class A, we have two different virtual machines with these three IP addresses. Is the communication possible? Santosh, can you please unmute yourself and tell me, can justify like how you answer this without subnetting will not communicate? This is a class A IP address.
Yes. Hello. Can you
Yes, yes, Santosh, I can hear.
Sir, subnet. For example, 255
Okay,
is for last final.
I'll tell you the simple way. Okay, so this is the class A IP address.
Yeah.
Can you tell me how many network bit and how many host bit?
Two
For
network
class A
bit
it
and
is
two host
no.
bit.
For class A it is one network bit.
Okay.
No, can you tell me?
Network bit. Okay. Class A. Okay.
First is the network bit 1N and 3H.
Okay.
So communication is possible. As you can see here, the first octet, which is a network bit, right? This is same 10.10
Yeah.
class full.
Yes, sir.
So these are the host bit. So it doesn't care like what is the host bit. So it doesn't care. So since the network bit is same, it will communicate. But instead of 10 dot here, if it is was 11.10.2.0, then without the use of router, this will not work. I mean, this virtual machine will not communicate because the first bit has been changed. If I take one more example, I'll tell you the answer itself. So let us say that is a class B. Maybe I'll take 130.0.0.0. We have 130.0, 130.0.10.11. 10, for example. Now this is the class B. So the first two bits are the network bit and the two are host bit. As you can see here, you can see it here, right? So the two network bits, they are not changed. So they are same. So that's the reason that even they will communicate. So remember that, I mean, like even when you're creating the VNet and all, so this is important and you have to understand. Okay. So even in the interview question and all, they might be asking such simple questions just to know your basic concept of networking. So please remember that. So, just to repeat, the IPv4 is a 32-bit addressing scheme. When I say that the 32-bit, it is divided into 4 octets. Each octet is a 8-bit. So when I say 192.168.10.11, it is a decimal numbering system. But your system cannot understand that. So it can only understand the language of 1 and 0, which is the binary. So each octet can be represented in 8 bits. So that bit could be 0 or 1. So that's the first point. And the second point, talking about like how your system will understand is that by making use of the network bit and the host bit. So for the class A, we have 1 network bit and 3 host bit. For class B, it's a 2 network and 2 host. And for the class C, it's a 3 network and 1 host. So in order for the VM or the virtual machine to communicate with each other, the networking bit, they should remain same. So if the networking bits are same, so the communication will happen. If the networking bits get changed, then the communication will not happen. So we have studied till here last week. Okay, so this is what I wanted to repeat. So before moving on, is there any questions? So any question, then please let me know. Thanks. So hope that is clear. So we will move to the
I
next.
have a small question. It's not very small.
Yes, sir.
You told about VMs and IPs, right? So as an Azure administrator, like my responsibility will be like creating a VM, right? As per the customer's requirement. So network segregation and IP, assigning an IP to the VM and all that. So it should be taken care by a dedicated network administrator, right?
So see, if that is on premises and all, so there will be usually the dedicated network administrator. But what I have seen is that for when we talk about the Azure, we do not want to carry out the complex network operation. For example, we have a network engineer. I think Amir is the one who works on networking. So if there is something like which is too complex, like handling the firewall services or doing different kind of things, then there will be a dedicated networking team. So, but just creating the virtual network, then assigning the IPs, creating the subnet we will study. So these are all the very simple tasks which, as a Azure administrator, you should be aware. So if it is, I know, I mean, like even like in every organization, we have a dedicated network team. But the thing is that, I mean, if it is for very kind of advanced network concepting and all, so usually they will be having the team. But this operation which I told you, like defining the address space, creating the subnet or creating the VNet, so that is the responsibility of cloud engineer itself.
Sure. So we will be like sitting together with network guys and doing the stuff, right?
Yeah, usually, yes, the hierarchy will change anyways, I mean, company to company. But usually, I mean, if they think that, okay, like we have to, I mean, form a same team, I mean, the network team and the like other associate in the same team, then you might be having some kind of specialization. For example, if your team is a cloud engineering team, they might be having segregations like, okay, the first team is responsible for the networking only. The second team would be taking care of the other resources like the virtual machine app services, storages, etc. So that is also possible. But there is a second thing, but in interview, so for sure, definitely you will get questions on the IP addressing, the subnet and the address space. They will not go deeper and ask you the advanced questions like how you configure the switch and all, or what is a firewall device, how do you, or what is a routing table. They will not ask you such kind of big questions, but for sure you can expect the basic questions on networking.
So the interview will just check our networking knowledge, right?
Yeah, basic networking knowledge they will check, and it is essential also, because if you want to go to the cloud engineering, you should be having the basics of networking. When I say the basic of networking, I mean we will be covering like basic to advanced all the concept. So we have something called as the different load balancing services, and so usually as a Azure administrator, you will be taking care of that. So that load balancing services, and that is a module 8, which we will cover tomorrow, hopefully. So yes, you should be, I mean, whatever I cover in this module. So definitely, I mean, you'll be getting the questions out of that topic in interview as well as in your Azure certification exam as well. And based on your company's hierarchy, so that might change. You may be required to configure all this, or you may be required to configure the compute resources itself. So that is up to the organization. But anyways, like in every organization, there will be a network specialist person. So don't worry about that. So is it okay, Akhil? Yeah, is it fine, Akhil? Is your query?
Yeah, sure. We can continue.
Sure. Okay, so till now, like we have studied about the classful IP addresses. Like I told you, right, I was stressing upon the classful IP addresses terminology till now. Now let us just 1 minute. I'll be back. Just 1 minute. Yeah, sorry for that. Okay, so till now, like we have okay. Okay. Yeah, so till now, I told you about the structure of the classes, right? When I say the structure of classes, it's a class A, class B, class C, the network bit and the host bit structure. Now, we have to understand how your system will understand this. So I told you, your system will not understand the basic decimal numbers. So we have something called as a network bit and the host bit for that. But in spite of that, your system need another the one more mechanism to exactly segregate or understand which is a network bit and the host bit. So if you input your IP address directly to your system, so it will not be able to understand what exactly it is, right? So we have something called as a mechanism for this, which we call it as subnet mask. Okay, let me so the people from the networking concept or the networking background, they might be aware of that, but I'll explain that again. Okay. Okay, so always remember for each class you have something called as the subnet mask, and subnet mask is the mechanism or the key mechanism by which your system or the virtual machine will understand how many network bits are reserved and how many host bits are reserved for that particular IP addresses. So what we have written here, I mean, we should write it here. If I say the class A, for example, it is a right. We have one network and 3 hosts. So what I have written here, it is actually the subnet mask itself. Now, what exactly is a value of subnet mask? It is very simple to understand. The n portion you have, I mean, which is nothing but the network bit, convert it into the 255. Okay, let me repeat with what I have said. So usually for the class A, we have n dot h dot h dot h, which is the one network bit and the 3 post bit. And in order to, this is nothing but usually which we, this nothing but a subnet mask itself. But I mean, we have something called as the value for each subnet mask. In order to calculate that, what we have to do is that the n portion which we have here, we have only n portion, right? We have to convert it to 255. 255. So why 255? Because what we are saying by n, I told you clearly before that we are seeing these 8 bits are dedicated for network portion, right? So when I say that n, so the first bit, these 8 bits, they are dedicated for network portion. And if you convert this value, like we have already seen that conversion, which is nothing but 2 to the power 8, it will become 2 to the power 56. But we write it as 255 because I told you like how we can do the calculation. Just forget about it. So usually we'll write it as 8 times 1, right? When I write 8 times 1 and I'll do 2 to the power 0 plus 2 to the power 1 till 2 to the power, the last bit is a 2 to the power 7, which is the 8th bit. If I do that, it will become the 255. So I'll write you a simple chart, okay? So it might be helpful for you in future. Always remember that. So usually we'll be having the 8-bit sum is 128. We have 64 as a 7th bit, 32. We have 16, 8, 4, 2, and 1. We calculate these 4, 5, 6, 7, 8. Okay, so now you might be thinking why you want 128. The 2 to the power 7 is a 128, right? So I told you this is a 2 to the power 0, and this is the 2 to the power 7, and these are the 8 bit. So 2 to the power 1 means it's a 2, 2 to the power 2 is 4, and so on. 2 to the power 7 is 128. Always remember this chart if you want to do any kind of conversion. So when I say n bit or the n portion, it is nothing but you have the 8 n's, right? Or the 8 bits are, they are nothing but 8 ones. So if I make a sum of that using this table, you can see here, wherever I have 1, I have to use that particular bit. So since this is a 1, 2, 3, 4, 5, 6, 7, 8. So since it's all 8 ones, we have to do the sum and we will get the value as 255. Okay, so that's the reason that for the class A, the subnet mask is, when I say the value is the 255. Okay, and using this table, like I told you, like wherever 1 you have to add that, and if there is any 0, you have to ignore that. For example, if this was 0, then you cannot add 2 here, right? So this value is 0. I mean, this bit is, if this bit is 0, there is a second bit is 0. So you cannot add that. So usually we know that the total addition is 255. And if I ignore this bit, just remove 255 minus 2 because we are removing this sum. So what we'll get is that 253. So similarly, you can do the conversion for 192 and so on. Okay, so you can do that conversion later on. Okay? So for the class A, we can represent this subnet mask as 255.0.0.0. You might be thinking why 3 zeros, right? Because I told you the first n bit is reserved, which means that I should be having all the bits as 1. So which we already have, and we have seen the sum is 255. And the remaining host bit, they will be 0 itself for the subnet mask. I mean, for the class A IP address. So that's the reason that we can represent the subnet mask for class A as 255.0.0.0. For class B, it is 255 because 2 network bits are reserved, right? And for class C, we have 255.0. So this is the third, I mean, because this is because we have the 3 network portion and 1 host bit. So that's the reason that I mean, we are representing this in this way, in this manner. So this is what we call it as the subnet mask. And with the help of the subnet mask, your system will be able to understand how many network bits are associated and how many host bits are associated. So going a bit deeper into that, which is the essential concept, we can also write this subnet mask instead of like doing 255.0.0.0. This can also be represented in one more way, which we call it as the CIDR notation, or classless inter-domain routing, or CIDR. So some of you might be aware of what exactly is a CIDR, and most of you might not be knowing that. So let me explain the CIDR, which is a classless inter-domain routing. Okay. So this CIDR, this came into the picture when we moved on to something called as the classless IP architecture. So as of now, we have studied that if the IP address belong to class A, class B, class C, based on their IP address range, right? For example, class A is 100.0 to 127.255.255. Class B start from 128.00 to the 191.255.255, and class C, like we have seen, it is a 192 range to 223. So this is how we usually used to do the classification of the IP addresses. So later on, we moved on to something called as the classless IP architecture. When I say classless IP architecture, it means that, okay, so let me take one example. When I write this 192.168.0.0, by whatever we have studied, you will now immediately say that this is a class C IP address, right? So that is what we have understood. When we say that classless IP, when I write this particular IP address, this cannot be classified as the class C IP architecture. I mean, we are not assigning any class to that. So when we move on to the classless IP architecture, so instead of writing the subnet mask as 255.255.0.0, for example, for the class B, we came to a concept called as the CIDR, or classless interdomain routing. So when you go to the classless method, we have the CIDR number. So for this class A, just to, just for your understanding. If you take the class full IP again, you know, right, for subnet mask it is 255.0.0. And the CIDR notation for that is /8. Okay. Now, why 8? Because we know that how many bits are dedicated for network bit for the classes. It is 8 bit, right? I told you it's a 1N portion and the 3H portion. So that's the reason that it's a /8. For the class B, we know that the 2 network bit, right, which is reserved. So 8 plus 8 is a 16. So that's the reason that it's a /16. And for the class C, as you can guess, it is nothing but /24. This is for class C. So if I talk about the class, if I talk about the class full IP address, and let us assume that we're talking about the class full itself and not the classless. When I write a IP address, which is 192.168.0.0, by default, its CIDR notion would be 24. So this is how we will represent the class C. And if I write a class A IP address, which is 10.0.0.0 or 10.0.0.1, the CIDR notation will be /8. And for class B, it is 132.0.0.0/16. By default, this is how we write the CIDR notation, or the subnet mask, also we can say, in this fashion. Okay. And as you know, when I say the /8, the subnet mask would be 255.0.0, and for the class B, you have it here, and for the class C, you have it here. So this is how which we usually do the denotation. Now the point of CIDR or the classless inter-domain routing is nothing but, since I started representing with /8, the same IP address, it can be represented with /24 as well. What I'm trying to say is that I told you, right, by default, in the class full architecture, when I write 10.0.0.0, for example, you will say that, okay, the CIDR notion would be /8 because we have the class full IP address. But as of now, we have moved on to something called as a classless IP itself. So it is possible that I can also write it as /24. So the difference I'll tell you. The first IP, you can see it here, right? So obviously this is the class full IP address itself, because this belongs to the class A, and for the class A, your subnet mask or the CIDR has to be /8. It cannot be /16 or /24, etc. But if I remove this concept of the class full IP architecture, and if I move on to something called as a classless, like none of the IP addresses, like any of the IP addresses, they do not belong to any class. When I say the class, it is class A, B, C, or for that matter, D and E. So they could belong to any class. So in that case, what happens is that your class A IP address, it is not chained or it is not stick to /8 denotion, right? So I can write it as /24. For example, for the class C, we have 192.168.0.0. Default should be /24, right? I can write it as /16 as well. So this is a concept of CIDR we have. So what it basically means is that class C IP address, which is 192.168.0.0, now acting as class B, because for the class B, we have the denotion as 16, right? The default value, it was /16. Now you can see that using, we have converted this, or we have made our class C IP address to act as the class B IP address, which is by using the CIDR ranges /16. So this is what we call as the CIDR or the classless routing method. Okay. And also one question, do you think that, write it here. We have now seen the standard the networking bits, right? I mean, /8, 16, 24. If I write it as 10, 0, 0. Now, henceforth, we will be talking about classless IP only. So I can write the /16 or /24 as well for my class A IP. So even in Azure, like while doing the demo or while working in real-time environment, I mean to say that in the corporate real-time project, we go for the classless IP itself. So I explained you class full IP address so that you should be knowing what exactly is the class full IP address, and it was easy for me to explain, and it was easy for you to understand this denotion. Okay. Okay. Now, can anyone tell me, is this denotion possible? So till now we have studied that we have /8, 16, and 24. Now we came to know that the IP address can belong to any class in the classless architecture by using the different CIDR denotation. We have /8, 16, 24. Right? So can someone tell me, is this possible? 10.0.0/25? You can confirm in the chat as well. So I need an answer from at least one or two. So can you tell me 10.0.0/25 is this possible? Can someone confirm in the chat? If it is a wrong answer, then it is fine. So can someone tell me if 10.0.0/25 is this possible? Now Neeraj, Santosh, Siraj, Vishal, Amir, Akhil, Neeraj.
Not possible, I think.
No, the answer is it is possible. I'll explain. Okay. So I'll tell you what exactly is the difference. For example, let me take the example of Yes, let me take the same example. Let us say that we have the IP address 10.0.0.0/24. What is the subnet mask for that? We know that, the subnet mask for this, since this is at 24, it means that the three network bits, right? When I say that 24, it's 8 plus 8 plus 8, which calculated as the 3n portion, right? So we can write the subnet mask as 255.255.255.0. So this is our subnet mask, right? Now with the /25, what I'm trying to say is that, let me, so here we have 8 ones, here also we have 8 1, here also we have 8 1, right? And the last bit which we have 0 here, so this can be represented as 8 times 0. Okay, so this is how it represented, and these 8 ones means 1 1 1 1 8 times. So this is how this is represented. So when I say the /25, what happens is that okay, usually if you see this diagram, we have 8 bits here. Each bit is dedicated for the network portion, and if I calculate the number of ones, it is nothing but the 24 I'll have. Now, when I say /25, what I'll do is that I'll take one more bit from the host bit. So I told you, I'll explain you. Here we have 8 bit, right? Anyways, even if it is a 0, in the binary denotation, in the binary, it is represented at 8 zeros. When I say /25, it means that I should be having 25 ones. It's a simple concept. When I say /24, I will say it is the 24 one, right? So this is the denotation which we have. In the host bit, it is all 80. So when I say /25, what I'll do is that I'll borrow this one bit from the host. When I borrow this, what happens is that this one particular 0, it will become 1. And remaining all zeros, which is the 7 zeros, they will remain same. So in that case, now we have 24 ones here, and one more one here in the host bit 25. So adding these two, what happens is that we have the 25 network bit. So till this portion, we have the network bit reserved for that. So we have, let me explain what exactly we have done. So when I say the /25, so the first 24 the 8 bits, or the first 3 bits, we have the number of ones which we have is 24. If I want to take /25, what happens is that in the host bit, I have to borrow that one, because we do not have any other place to take ones, right? For the network bits, it's already all the 8 bits are taken. Now when I say /25, we have to do something. We have to take one from at least one host bit. So that's the reason that I have taken one from here. So now this 80 becomes, what happens is that the one bit would be 1, and rest of them would be 0. Now if I convert this value, what it will become, right? So I told you, if you remember, we have the chart here. Always remember this chart, okay? So I told you now that we have the value as I have 1 here, because that one host bit has been changed to initially we had 8 zeros here. So that's the reason that the total count was 0. Now we have taken one host, the first bit from the host octet as 1 here. We have converted to that one. So this has become 1, and all other 7 zeros remain same. If you use this chart, and if you do the calculations, I told you, like, if there is any 0, you have to ignore this value, right? So I can ignore from these 7 bits, starting from 1 to 64. But since I have on the 8th bit, I have 1. So the value which I have is 128, right? So now what happens is that my subnet mask will become. So the first octet, it remains same, 255.255.255, because we haven't done any changes. So since I have written it as a /25, I have converted, I mean, I have taken one host bit from the network. I mean, one bit from the host, which has become network bit now. So it has become 128. So this is the subnet mask, which we have as of now. So similarly, just to tell you, like we can also represent the CIDR notation. I mean, not only as /25, we can also have /26. We can have /27. We can have /26, /27, /28, /29, or even for that matter, /17, /18, etc. Okay, so we can have these CIDR notation as well, and you can convert that and you can get your subnet mask. Okay, now I'll explain you. So considering this example, 10.00/25, if you give /25, what is the after effect that I want to understand? Okay, so if it was /24, what happens? We know that we will be having a flat network with 256 IP addresses, because I told you when I say /24, we have three N portion and one H portion. When I say one H portion, so it is 8-bit 2 to the power 8, which is nothing but the 256 IP addresses which are available. And obviously you have to remove the 2 reserved IP addresses. We have the 254 IP addresses. So though it's a class A with /24 CIDR, it becomes class C, right? So this usually, I mean, we always said that 10.00 is a class A, but with the help of the CIDR notion, so this class A has become the class C IP address. Now the VMs in this flat network, they will communicate with each other, right? Obviously, yes. But if the /24 becomes /25, in that case, what happens? Let me tell you. So I told you here from this host bit, you have taken one more extra, right? I mean, initially it was all the 8 zeros, but when I say this /25, we have taken one host bit here. And when I say the network bit, it is mandatory that the network bit has to be always 1. So that's the reason that I have taken one host bit here. And if I can represent till here, this has become your network bit, right? Till this first digit of this host bit. So this has become your network bit, and these 7 digits here, they have become your host bit. So here from the host bit, like I told you, you have taken one more extra, and we have 7 bit which is available for host. I hope that is clear to you. So which means that your network now will be divided into 2 equal parts. Okay, and it will become, let me send it here. So, 0.0.0/20. Okay. So what happens is that your network it is going to split because of that. So the first segregation, your VMs will be having the IP addresses starting from 10.0.10.0.0.0 going up to 10.0.0.127. Okay, that's the first segment which you will be having. And in the second segment, you will be having like 10.0.0.128, then 129, 130, so on, up to 10.0.0.255. Okay, so this is how your network will begin. So 2 different network right now, and both of them will be having the 128 addresses available. Your usable IPv4 IP addresses become starting from 10.0.0.1 ending with the 126 in this first network, because I told you the first, this would be the network bit and this would be the broadcast. Same goes to here as well. So the first segment, it will start from point 0.1 ending on 0.126, and here 0.129 to 0.254. Right, so this means within the first network, the virtual machines, I mean, whatever virtual machines you have in this particular range, they would be able to communicate with each other. And so here also they will be able to communicate with each other. So basically, your network is further reduced into the smaller chunk. So if you want to create a very small network, you can go to /26, then /27 as well. So usually they will start, I mean, shrinking your network, and they will divide your network into smaller parts. Okay, so I will tell you what happens. So let us say that, I mean, if I do /26 here, we will be having the 4 network. Okay, I'll explain how 4 network. Because I told you we have the 32 bits as the representation, right? So you have to always consider that 2 to the power 32. So minus 26. So when I say that the /26, this is nothing but your network bit, right? So just subtract that network bit here. So the formula is 2 to the power 32 minus n. So remember this formula. So in this case, when I say /26, it's a /26. It is nothing but 2 to the power 6, right? And 2 to the power 6, if you do the conversion, it becomes 64. Now you need to calculate and I told you that usually, I mean, when I say the /24, I mean, which is the standard denotation, I told you that we have 256 addresses, right? So if I want 256 IP addresses are available, and let me say that we have already 64 IP addresses here, and I will put how many networks I have. So if you do the calculation, it's 256 into 64, which will become 0.4. It might be little, I mean, kind of, it might look complex for you, but as soon as, I mean, you explore more and more onto this, it will become easier for you. So just remember, like, whenever you want to calculate how many number of networking you can do, so the formula is 2 to the power 32 minus n. So here I have 26, so I'll become the 64 IP addresses, right? And at any point of time, you know, right, that we have 256 IP addresses available for us after the /24. So that's the reason that if I divide that by this 64, we'll be getting the 4 networks. So my range will start from 10.0.0.1 to 0.63, and second will start from 0.64 to, again, you have to add, it will come across 127, and so on. So your network will become 4. So similarly, if it is 27, it will become, your network will be reduced to 8. So basically, the advantage of doing is that you can reduce your IP address wastage, right? For example, if you take class C IP address, you will always get 254 usable IP address, which we have seen here. Now, what if I have only 10 machines which are available to me, and at any given point of time, so I'll be using only 10 virtual machines. So it means that out of this 254 IP addresses, I will be assigning 10 IP addresses, and I have 244 IP addresses. So I'll be simply wasting that. So it's not a good thing, right? So you should not waste any resources. It could be the IP addresses also. You should not waste them. So because of that reason, we have to reduce the network size as per our requirement. So the thing which I have explained here, this is called as subnetting. Okay. So whenever I say subnetting, it is nothing but dividing a larger chunk of your network space or the network ID into the smaller parts. So this is the concept of the network, the subnetting. Okay, so yeah, so this is what I wanted to explain before we can go ahead and create the video. So any doubt in this subnet concept? So any queries or questions? That no questions are. Okay, let's do a small demo. Let us create a VNet and let us exactly understand like how to create that VNet. So as of now, you can remember like whenever we have created the storage account or app services or AKS cluster and all, we have, I mean, I have told you that, I mean, I had skipped that networking tab because I told you that like we'll be covering this in a separate module. So today we are going to cover like how to create the VNet and and so on. So in the portal, you have to search for something called as a VNet, or you can simply type VNet or virtual network. So open that. Go to the create. Uh, Let me create a new resource. So I said demo arching one. Okay, let me give the VNet address name. VNet name. Maybe I'll give it as VNet test. And I'll use the East US itself. So I'll go to next. I'll go to next. So here you can see now, right? We have something called as the IP address tab. So this is where we define the address space. You can see here, it has taken a class A IP address, right? 10.0.0.0, but it has applied a CIDR value of /16, which means that class A IP address is now acting as a class B IP address. So this is a classless IP address. Now you can easily grasp what exactly does it means. Right now we totally have 2 to the power of 32 minus 16. Because in class B, I told you, I mean, when I say just /16, it is nothing but the two network bit and 2H bit, right? So when I say /16, it's a 2N portion. So when I say the 2N, it is 8 plus 8, 16. The total available is 2 to the power 32. If I subtract that, we have 2 to the power 32 minus 16, which is nothing but 2 to the power 16 is 65 address, total addresses. So as you can see here, they have done the calculation and they have told you that, okay, we have 65,000 IP addresses available, right? So you can change your CIDR donation notion here. You can see as I'll explain, I mean, the smaller the number of CIDR, the larger the network size, and the greater the CIDR number, the smaller the size. Okay. So for example, I mean, this example, I'll take maybe the class B IP address. Let me take a separate IP address. Maybe I'll take 1.0. So I'll take this simple IP address range. So I have 1000. I'll take the CIDR notion as /16. Now, the concept remains same. We have the 65,000 IP addresses which are available to us. So this has to be divided into different segments, right? Because I told you 65,000 IP address means it's a large address space. You might not be having, I mean, those many number of devices in your project, right? Or in your scope. So that's the reason that it is essential that we have to divide this larger network into the smaller part, which we call it as the subnetting, right? So by default, it has created a subnet for us. You can see it here, 1000.210, and it has taken /24 as the CIDR notion. It means that out of the 65,000 available address IP for us, it has created a smaller network space, and you can add the 256 IP address here. Now, if you want to add one more subnet, and usually like in our corporate environment, at least you will be having the 4 subnets in your environment. So let me tell you like how to add the subnet. So you can click subnet here, add a subnet, and The purpose usually we keep it as a default. You can give a name. I'll say that it's a test subnet. And so it, as you can see, right, 1000, it has already taken, so you cannot repeat that, right? And when I say /16, so I cannot do 1.1.0.0 as well, because /16 means the 2n portion, the networking portion, we cannot change that. And the address space which we have already specified here. So from this address, it is taking this particular IP address. I'll show you if I do this as 1.1.1.0. Okay, so it will tell you that this does not belong to this. That's the reason, because you cannot change the second bit here. So that's the reason that I mean, we cannot change the first 2 bits, because it's a /16, and in our address space we have 1.0. So it is not possible that we cannot I mean that we can split that. So that's the reason that we have 1.0.1.0. So it has and you have okay, I want to explain one more thing here. So we have something called as a subnet delegation here. Okay, so subnet delegation means, so let us say that you have the different environment. Okay? So we have the compute or something. Okay, let us say that I mean you want to dedicate this subnet to a particular Azure services, right? For example, I have here something called as the Microsoft DB for Postgres, right? For the flexible server. So don't worry about what exactly is it. This is nothing but, I mean, you might have heard of a database called as the Postgres database. So Azure is also providing that Postgres database. So when I say that delegate this subnet to a particular service, it means that if I create a virtual machine and if I try to attach my virtual machine to this particular subnet, which is the test subnet, it will give you an error stating that this particular subnet is dedicated for Postgres database server. So that is what it means. So if I give it to MySQL, it means that only MySQL servers that can be associated to this particular subnet. So that is the option which you have. If you do not, I mean, if you do not want to dedicate a particular subnet to any of the Azure resources, you can click it as none itself. Okay, so it is changing. Okay, so now click on it and click on review and create. Click on create. So this concept, I mean, these are the very basic concepts that as a cloud engineer or the cloud administrator you have to know. I know that, I mean, this might not look easy, I mean, when compared to the other Azure resources. So if you have any kind of queries and all, so please stop me and ask your queries. Okay? So it is I mean, it is important that you will be clear with the concept of networking. When our virtual network has been created, I'll go to the VNet. So let me show you something, address space, right? So, I mean, we usually do not use this 1.0.16. Usually we'll go for 10.0, something like that. But that IP address, like Santosh asked me while starting the session that can we have the same IP addresses for the 2 companies and all, right? So for a demo purpose, I mean, we have a concept called as a VNet pairing. For that purpose, I have already used the 10.0 address space. And if I try to create that VNet again with the same address space, I'll be getting the error stating that it is conflicting. So that's the reason that I have selected this one. So won't usually go for 1.0. So this may not work properly. So just for demo purpose, I showed you this. So as you can see here, this is the address space here. If I go to the subnet, you have the two subnets available, right? Now, I told you initially when explaining, we have 256 available IPs and usable IPs are 251, the 254. But here in the Azure, you can see it here. It is saying 251 rather than 254, right? So I told you the two IPs are always reserved. One is the network ID and one is the broadcast ID. So deducting these two IP addresses from 256, it means that we have the 254 IP addresses. But what happens, but as you can see here in Azure, like instead of having 254, we have three IP addresses missing, right? We have 251. The reason for is that uh, they are reserved by the Azure for specific requirements. These requirements are nothing but one IP is for the gateway and the two for the DNS. We'll see what exactly is the gateway and DNS again. So just remember that. So if it is your on-premises network, usually like we have 254 available IP. But in case of the Azure, we have 256 minus 5. The first two IP addresses which remain same, network bit and the broadcast ID, and the three more are reserved for Azure. The two IPs are reserved for DNS, which is domain name resolution, or domain names, and one IP for gateway. We will study about this concept shortly. So I'll explain that time what exactly is a DNS. Okay. So let me quickly create a DN and associate or subnet to that. Okay. So yeah. Terminology. So I'll quickly do that. We have already seen that what exactly is this one. So I'll not be explaining this too much. We have covered it, right? So here in networking, like the topic which we have, which we have didn't cover previously, we'll see that. So it is not moving. This address space it is creating some issues. So what I'll do is that I'll set the class C IP address. We go with address space and let me try to change this space itself. So again, I mean, you will not be using the 192 usually. Maybe /16. Okay, we have the additional. I create a virtual machine, a new machine, and let me create a new VNet there itself. So the thing is that I have created already 2 to 3 subnets, and I don't know, these subnets are not working as expected. So, mm, some more subnets. Let me think this. Mhm. Mhm. So I have created the new VNet. Okay, and the subnet we have the 2 subnet here, the default and the front end. So I'll select the subnet which I have created, and it is asking for me a public IP which I keep there. But before that, let me enable the RDP. RDP is enabled, so we have the network, and let me click on review and create. So I'll click on create. So this VM is getting created. So I'll go to the virtual networks here, and just wait. Okay. Let me go to the virtual network here, and let me go to the subnet. Okay, till that VM is getting created, anyone is having any kind of queries or questions, please let me know. So if you have any doubts or if you have not understood any concept, please let me know. Okay? So this is a VNet which we have created, and if I go to the subnet, you can see here we have the 2 subnet created, the default and the front end, right? And it's a /24. /24 means that 3 network bit. So 1010 and 1011. As you can see here, the third octet, it is changed. So here it is 0, here it is 1, right? So that's the reason that, I mean, these 2 subnet cannot communicate. I mean, the virtual machine, which is assigned to the default, cannot communicate to the virtual machine, which is assigned to the front end IP address. So remember that. So I'll show you the demo for that reason. Okay, this VM has been created. So let me create one more VM. And let me show you the demo. So it will be easy for you to understand. So let me say that this is a VM of the VM. Okay, and let me take this time as Central India. I'll take the country as Central India itself. I told you, right? The VNet is region and subscription scope. So so in the networking, I'll select the same networking which is uh, So, yeah. So, like I told you, as you can see, this particular VNet, which was created in East US, right? So this does not belong to. I mean, this is not listed here. The reason is that because it is. If you remember, the VNet is a region scope. It means that the VNet within the same region can communicate, but by default, and the region in the different regions they cannot communicate by default. Okay, so what I'll do is that I'll make use of the existing the virtual networks. So I have basically give the name as PM India, and let me select this VNet itself. Okay, and I'll add it to the different subnet as you can see it here. Right? So I'll click on review and create. Let me explain what I'm doing. So I'm creating a two different VM and attaching them to the two different VNets, and we will see if they are able to communicate or not. So that is what we are trying to do. So for that reason, like I needed the different the virtual machines. So we already have one VM here, which was created in the East US. Right, and if I go to the network settings, and this is a virtual network which we have, right? This is a VNet which we have. If I go to this VNet, which is a VNet new, you can see here it is created in East US region. So the second VM which we are creating, it is being created in Central India region, right? So taking this example, let me take the RDP for this test VM. Let me copy this IP address, public IP address, and let me take the RDP. It's 13.82.169.197 and connect. This meeting completed. Let us see. Okay, so our first, the second VM meet is also completed. So what I'll do is that I'll take the RDP to this server as well. So Control C, RDP. So this was my this is my second VM, and this is my first VM, which was created in the US region, if you remember. And if I go to do the IP config,
नहीं होता, टाइम लगता है के वास्ते
if I do IP config here, so as you can see here, the first IP, I mean, it has taken the IP address as 10.1.1.4 because the subnet which we had assigned to this particular VM, networking setting. So this was our subnet, right? Which I had assigned. And if I go to the subnet, you can see here the subnet was 10.1.1.0. So that's the reason that it has taken the same, which is 10.1.1.4. So because this belongs to that particular subnet IP. So by default, it has taken this host bit as the 4. You can see here, I told you about something called as a gateway. So this is resolved by the issue. Okay, and if I go to the second VM, and I go to the CMD and if I do IP config, so you can see that the IP address is 192.168.0.4. Because if you remember, we have created a separate VNet region here, and this is how it was created, right? In 90. So, and the region, as you can see here, it is in the central India. And so now, what I want to do is that I'll copy this IP address here, and I'll go to my first VM. I'll do ping to the second VM. So as you know here that these belong to the different regions. The first region is the reason is this is in US region and that is in Central India region. And the second reason is being that, as you can see, the subnets are different. So the network bit, they are totally different. So this should not be able to communicate. If I do that ping, you can see here, right, that it is trying to ping that particular VM. And as far as what we have studied, this is not possible, and this was the expected outcome. So this should not be able to communicate with that particular VM. So this is what expected. No, but in your corporate environment and all, there is a requirement stating that, okay, I want to connect this VM. I mean, I want the communication to happen between these two VM. Okay, so there is an option for that. So we have as you can see, like I told you, these two VNets, they do not have anything in common by default, right? Now, in order to enable this communication to happen, I will go to one of the VM. As you can already, we have seen that result. The ping is not happening. So what I'll do is that I'll go to the India VM itself, and there should be an option. I think it should be on the head. So there is two methods for the communication to happen between the two VNet which are having the different the subnet IDs or the different address space of it. So the first method is the VNet to VNet peering, and the second one is using the connection gateway device. So let me open this slide and so this is the first option which we have, VNet to VNet peering. So as you can see in the slide, the virtual network peering, it enables you to connect to your Azure virtual network. Once paired, the virtual networks appear as one for connectivity purpose. What I meant to say is that once we do the VNet to VNet peering, when I say the peering, it's nothing but connecting. It is possible that the traffic between that virtual machine could be enabled by using this mechanism. As you have seen, we have not done any kind of peering. So that's the reason that if I go to this particular VM and if I try to ping that, it is coming that request time route, right? So that is the reason. I mean, by default, as we have studied, so it is not possible by default. So what we'll do is that we'll go to So we'll go to one of the VNet, and we have the option called as the peering here. Under the setting, we have something called as peering. Right, so we have to do this peering, and we have to check if this is working as expected. So I'll do a small demo. So I am in India VNet, right? So I'll click on add. So you have to give the link name. Let me say that it's IND US, right? Because like we have one VNet, as you can see here, we have one VNet in the East US region and one in the Central India region. Now we have to select the subscription and virtual network. So the virtual network which we have selected, it is nothing but we have used this particular, right? So I'll select this VNet IND. Cross verify. Go to the networking setting here. So I have VNet India, right? So this is my VNet name. So that's the reason that in the source, I'll be giving the name as okay. So this is the for okay. The first, what we have to understand that what exactly the VNet peering. VNet peering is a mechanism by which you can enable the communication between the two different VNet or the virtual network, which are having the different address space, or if they are assigned or if they are created in two different regions. Okay. So now it is asking me, I mean, so we have to go to the peering, we have to click on add peering. So it is asking remote virtual network peering link name. So the peering link name I'm giving it as India to US. This is the user defined name. Just for our understanding, I am giving that name. Okay. So in the virtual network, so you have to select for which VM you are trying to do that, right? So in our VNet, so this is a VNet Neo, so which was associated with that. So I'll select this one because this is saying remote virtual networks. Just remember, you are in this particular VNet, right? VNet IND. So when you give the remote, the virtual link, you have to give the name of when I say the remote, you can say that the next your destination VNet to which you want to do the peering enabled. So you have to select that option. So in the peering option, you have the different options here. So the first option is allow VNet Neo, I mean our Central Indian US, East US VNet to access VNet India. And it is asking to receive forwarded traffic. These are all not required as of now. In the local virtual network peering name, so since it's a remote first, so I'll write it as US to ING for better understanding. And here I'll say the local peering name. I'll call it as India to US. Okay, so yeah, I have these different options enabled. So what I'll do is that I'll click on add, and my virtual peering should enable. So in peering, what happens is that it's a two-way communication. It should happen, and the virtual network, they should be able to communicate with each other. Okay, so let us wait till this peering is getting created. So the purpose of this demo is that once the VNet peering is created, the virtual machines, they should be able to talk to each other. When I say talk to each other, it means that they should be able to, I mean, that communication from one virtual machine should happen to another. So let me, as you can see here, the peering status, it says that it's fully synchronized and connected. Okay, so I'll go to the same VM and to the P. Okay, much. I'll go to the second VM. We have missed something appearing. Disconnected. I think I have done some mistakes. So what we'll do is that, we will take a 15 minutes break, and till that time I'll check what exactly has went wrong. And after you guys come from the break, I'll explain. What fix I have done. Okay, so we'll take the 15 minute of short break. So please be back at 12:05. Okay. Please be back by 12:05 p.m. Till that time, I'll fix what exactly is happening. Hi, I hope everyone is back. So if we wait for 1 more minute and I'll start the session. Okay, I'll start the session. Yeah, I understood the issue. So in the previous virtual machine, the firewall was blocking the connection. So that's the reason that it was not happening. So I'll show you how to do the peering again. You might be having the confusion. So just to recap what exactly is the VNet peering. So as you can see, I mean, we have seen that the two virtual machines, which are part of the two different the VNet, uh, having the two different subnets or the address space, they are not able to communicate with each other by default, right? But in your real life scenarios, there are requirements. I mean, even if you are, I mean, promoted as the cloud engineer, I mean, if you get to work as a cloud engineer and all in your next company, so you will be having a requirement that, okay, you have to make the communication enable between these two VMs, right? But like as you, and it is highly, I mean, not uh, I mean, the chances of creating the flat network in the real life IT scenarios, they are very less. I mean, I'm not saying that there are no flat networks created, so there are, but most of the times you have to do some kind of the peering or the connections and all. So that scenarios you might face in the future, right? So in order to enable the communication between the two, the virtual networks or the VNets, we have the two connection mechanism. One is the VNet to VNet pairing, and the second one is the using the gateway device. So the first option we are exploring right now, which is the VNet pairing option. So what I've done is that like I have deleted this pairing which I have created, and the problem I believe that it was a firewall that is blocking. So I'll do the one more attempt right now. Okay, so I'll go to the, we have the two virtual machine right now, as you can see here. So we have the virtual machine test VM. It is in the East US region, and the VM India, it is in the Central India region, right? And the VNets, they are different. The address space are different, and they are in different regions. So by default, the communication between them is not happening. So that is what we have understood. Right. So now what we'll do is that I'll go to the virtual. I mean, you can go to either of the VNets, whether it is for US or Central India. So just for this demo purpose, what I'll do is that I'll go to the I'll go to the VNet of the India machine, which is the subnet is VNet India. Okay, which I have it here right now. So just scroll down, you'll get an option called as the peering under the settings. Right, as of now, I have deleted their peering. I'll click on add. So it is asking for pairing link name. You can give any name as you desire. So when I say that remote, it is nothing but it is a destination. As of now, your source is VNet India, right? So your remote is US. So what I'll do is that I'll just give name as US to IND. You can give whatever name you want. And you have to select the virtual network. If I select the INET India, this is not a valid, right? Because you will get a message stating that a virtual network cannot be paired with itself because your source is VNet. You cannot select the destination as VNet India itself, right? That is, it doesn't even make any sense. So now we are trying to the peer or connect to our US counterpart, right? So this is the VNet which we have, which is VNet Neo. If you want, I'll open this virtual machine. And if I go to the network setting here, under the network setting, you can see this option, right? Virtual network subnet, which is a VNet link. So this one I have selected here. And the first option is allow VNet to access VNet India. I have selected that. And if you want to remove, I mean, if you want to receive any forwarded traffic from VNet India, you can do that. And in the local link also you have to do. Maybe I'll, local means your source. I'll put it as India to US, right? Because we need two-way communication to happen. If I remove this option, it means that only the one-way communication will happen. That is from India to US, and from US to India, it will not go. So that's the reason. I mean, that option also you can do. So you can select whatever options you want here, right? So just click on add. So always remember, you might be, if you, I mean, if in the interview, if they ask you the question stating that, okay, I want to connect the virtual network or the VNets, but only the one-way kind of communication should happen. So what you will do? So you can give the example here. You can say that, okay, I'll set up the remote virtual network peering settings. And for the local, just explain what exactly you have done. And you can say that for the local, I will uncheck the options which we have, that is to receive the traffic. In that case, what happens is that the communication will only happen from India to US. I mean, the ping will work from India to US, but vice versa is not possible. So that one kind of scenario they might ask you. So just remember that. Okay. As of now, like I have enabled two-way communication. So what I'll do is that I am already on this virtual machine, which is my India virtual machine. Okay. Let me cross verify. I'm on the India itself. This is India, and if I go to the overview, you can see the public IP address here, 454. So just for this demo purpose, I will disable the firewall. In real case scenarios, you will not do that. There will be a lot of different mechanism, which is not required as of now. So just for this demo to happen, what I'll do is that I will disable the firewall. You have a function called as firewall.cpl. And you can see the option here, right? The turn off Windows Defender firewall on or off. In your laptop also, you might have seen, you might have done that. So I'll turn that off and I'll click on OK. So your firewall is completely removed right now. So I hope this time this will work. I'll go to the CMD and let me take the US ping ID. This VM is a US ping. I'll Okay, if it is working from other machine. Yeah, so it is working. So the firewall I should have disabled in both the machines. Okay, so that was a mistake. So as you can see here, previously it was not working. So now you can see that if I do the IP config, so it is now working. Okay, so just for the demo purpose, I have disabled the firewall, and in real case, you will not do that. Okay, so this is the concept of IP VNet peering. So any doubts or questions before proceeding to the next one, next topic? So any queries, any questions, or it is clear? Can you please confirm in the chat, please? Okay, thank you for confirming. So yeah, I mean, if you have any queries or questions, do not hesitate to ask me because you have to understand this concept. Okay? So anyways, I mean, proceeding to the next way of communication, I mean, the next way of connecting, which is nothing but the gateway devices. So yeah, before going to the gateway, so I just wanted to tell you something about VNet peering as well. Okay, so this VNet peering, which we have just done the demo right now. So it is classified into two categories. One is a local peering. Second is global peering. Okay. Now the local peering means if your two VNets are located in the same region. I mean, let us say that like you will be having, obviously you will be having the different subnet. Okay. But they are located in the same region. For example, two virtual machine in the central India. So in that case, if you establish the peering between them, then that is called as a local peering. And global peering is nothing but which we have done right now, right? We have taken the central India as well as the US. So that is a example for the global peering. So peering, this VNet to VNet peering, it is the latest feature which we have. Before that, we had something called as the gateway device connection. So remember that. So before the VNet to VNet peering option was enabled, we had something called as the gateway device connection, which we are going to talk about right now. But the most popular way of connection is VNet to VNet peering. So remember. So now let me talk about the second way of enabling communication between VNet, and that is nothing but the VNet to VNet connection using gateway device. So let me go to the slide. So this one. So we know that in the case of peering, it works without the need of additional device, right? So we have not configured any additional devices. I mean, like we just had the virtual machines, and what we have done is that we have done the peering enabled between them. We had not configured any routers or gateway devices or switches or any kind of for that, right? So in that peering, and it was simple. So we had not done anything as such. But for the gateway connection, you need something called as the gateway device. So let me take you to the whiteboard. But before that, let me delete my virtual machines. Else I'll not be able to do the demo later on. So what we have is VNet to VNet connection using gateway device, right? So let us say that we have the two sub VNets here. So this is my first VNet. let me say that I have one VNet here, and let me call it as VNet 1. Okay, and let me go another VNet here. So we have seen, right? We have the two different VNet. So this is my second VNet. So the two different VNet here which we have, between them you want to establish a connection right now. Right now, why we need to establish the connection, because their subnet is different, or their address space is different, or they might be in some other region. So that's the reason that we are doing this, right? So in order to establish that, we need something called as a gateway device. In both of the VNets, in both of this VNet, we have two subnets called as the gateway subnet. So always remember, whenever you create the VNet to VNet gateway connection, it is mandatory that you have a dedicated subnet for that. So let me write it here. So you have something called as the gateway. I'll write it in small short form. So gateway subnet here, maybe gateway subnet 1. And for this, we have the gateway subnet 2. Okay. So a gateway sub now let us exactly understand what exactly is a gateway subnet, right? So I told you, like, whenever you go for the second way of communication, we'll be having a gateway device, and each of these VNet will be having a dedicated subnet, which is called as a gateway subnet. So the gateway subnet is nothing but a subnet where a network's gateway resides. Now, the gateway is a device that routes traffic from your local network to the external network. Okay, so remember, so we have this earlier setup, we have two VNet, and we have a dedicated gateway subnet, and we have something called as the actual gateway here. Okay. Here also, we should be having gateway device. So repeating, the gateway is nothing but a device that routes a traffic from your local network to the external network. So this is the local network talking about this particular setup, and this is the local network talking about this particular setup. This V2 is an external network for the VNet 1, and for the VNet 1, or for the VNet 1, the V2 is the external network, right? So you can understand that. So one subnet in the first, okay, so we have a subnet in the first network, which is called as the gateway subnet, and we have the same in second two. This one. And now within this gateway subnet, you will add a device called as the virtual network gateway device, as you can see here. So you need to add a virtual gateway device. So it's a virtual, it's not a physical device like as you have to manage in case of your own premises. So once you have added this VNet gateway, or while adding this VNet gateway device, you will have to provide a public IP for it. Okay. So I'll write it down here. So as of now, just remember the procedure. So here also I have the public IP, and here also I have the public IP, right? And this is a common sense, I mean, which we can make out, right? So these two are completely isolated environments. I mean, they are in the different subnets and all. And we want to, and we have connected something called as a gateway device. And always remember, the gateway device is always be associated with something called as the external, the public IP address, right? Even in case of your on-premises environment and all. If you want to connect to your the WAN or the wide area network or the internet, your packet will flow to the gateway, and from the gateway it will connect to the internet using the public IP internet. So the same concept, it is available right now. So which means that now we have the two subnet in both of these VNet. We have we have the two VNet, and in both of the VNet we have the two subnet called as the gateway subnet 1 and gateway subnet 2. And therein we have the gateway devices connected here, and each gateway is associated with the public IP address. Okay, so you can see you got two public IP addresses right now. One is here and one is here. Now between these public IP addresses, you can establish the connection. Okay, so we make it different color. So this is how you can establish the different the connection between these two. Now, what kind of connection? Okay, we will create a connection which we call it as remember this terminology, VPN tunnel. So this is what exactly is happening. So repeating, like we have the public IP addresses associated with each of the subnet, with each of the VNet, and the communication between these two, it will happen via the public IP address only, right? Like I told you. But what kind of connection exactly is happening is that we will create a VPN tunnel between these two. So between these two now, VPN tunnel is being created, and this is the way how two VNets are getting connected. You know, via the via this VPN tunnel, your machine in the first section. When I say the first section, this is the first section. So your virtual machine in the first section can talk to the other side using the private IP addresses. So remember that. So just don't get confused. So how the communication exactly is happening is that, okay, let us say that we have a virtual machine here. It is having a private IP associated with that. Here also we have virtual machine. Here also private IP is associated with that, right? So by default, these two VMs, they will not be able to communicate with the private IP addresses just because they are not in the same region, or they might belong to a different address space. So in order to enable the communication in the first way, what method we have used is that it was a VNet peering. So all this kind of this complex mechanism, which was not required, right? But in case of VNet to VNet connection gateway using the gateway devices, we have to follow this procedure. So at the end of the day, please remember that private IP to private IP connection is happening between these two VMs only. Okay. So what you have to do is you have to create, you will be having the two different VM. You will be creating a dedicated subnet. And on that subnet, you will be having a gateway device associated with it is a public IP address. So this public IP to public IP connection happens via something called as the VPN tunnel, right? Using this VPN tunnel, these two virtual machines in the two different sections, they would be able to connect using the private IP addresses. And just to tell you, you can use this VPN tunnel to connect to your on-premises as well. Okay. So I told you, right? I mean, in the initial class, we'll be having the hybrid cloud environment and all, where we would be utilizing the on-premises as well as the cloud environment. So suppose let us say that you have some of your virtual machines, some of the devices which are connected on to the on-premises, and you might be having some of the devices or the resources which are kept in your Azure cloud environment. So if you want to make that connection happen, that hybrid connection happen, you can use the VPN tunnel for that using the VPN to VPN connection gateway mechanism. Now, what is the property of a VPN? When I say the VPN tunnel, VPN, it is nothing but the VPN tunnel. That even like in your like organization and all, if you are doing work from home, if you want to connect to your organization, you will be having some the Cisco VPN and all, right? So you can relate the similar mechanism with here. Okay. So a VPN, let us see. Let us understand what is the property of VPN. A VPN connection is always encrypted. So remember, right? That is a important point. A VPN is always encrypted. It means that if any kind of hacker or the attacker from the external side, even he will not be able to decrypt or he will not be able to perform any kind of attacks on the packets which are being transmitted. Secondly, the minimum size of the gateway subnet is /27. Now, I hope you exactly understand what exactly is a /27. It's nothing but the CIDR notation, right? So, which provides 32 IP addresses for your dedicated gateway subnet. Okay, so for example, you may choose for the gateway subnet as 10.0.255.0/27. 27, for example, 10.0.255.0/27. So this would be example for the subnet range for your dedicated subnet gateway. So this is what we have in the VPN to VPN connection gateway. Now let me do a demo. Maybe like when we do the demo, it will be more clear for you. Okay, so just hold on. Let me check if the virtual machines are deleted, because I mean we have the quota issue sample, so that's the reason. And let me go to the VNet. And so the thing is that I mean this the demo for this, it will take approximately, I mean if you want to create the gateway and all, it would approximately, it will take 25 minutes to create. Okay? So that's the reason that I have already created that the gateway, but I'll show you how to do that. Okay, so first let me delete the peering, which I have done here, because if I have the peering enabled, so it will not work. It will conflict and it will not work. So that's the reason that just let me delete the peering which we have done. So if you want to do the demo for that, the VNet to VNet connection gateway in the portal, just search for virtual network gateways. Just click on that. You can see here, I have already created the two gateway. If you remember, I mean, going back to the diagram, we already have the VNet present, right? I have VNet India and VNet US already created for that. And I told you we have to create a dedicated subnet, right? So before doing that, it is better that I'll so let me go to this. This is a VNet which we have, VNet India. And if I go to the subnet here, you can see here I have already created a gateway subnet. And always remember, this is when I create the subnet itself, you have to select the purpose for that. If you remember when we created the VNet for the first demo, I have selected the option as default here, right? Let me show you. If I click on the subnet here, we have selected the default here, right? So I told you the virtual network gateway, it should be a dedicated subnet for the gateway device, right? So that's the reason that you have to select it here. And the name, it will take by default this only. So for the subnet, you can give, for the other subnet, you can specify whatever name you want. But for the gateway subnet, this is the standard and or the default name, and this cannot be changed. So similarly, I have done the same thing for the VNet US as well, and I have created the subnet for that as well. Okay. So the next step is that, like I told you, so this gateway subnet is dedicated connected. We have to connect. We have to create something called as a gateway device, right? Because gateway device is the one which enables the communication via the VPN tunnel. So that's the reason that going to the portal, virtual network gateway. So I have already created that, because each gateway, it will take approximately 20 to 25 minutes to get created. So I'll show you like how to create. Then I'll not exactly create because we already have that, and I'll do the next part of the demo. Okay? Just click on create. So in the name, like maybe you can give the name as, say, INT1. And in the region, for example, let us take the example of India and the US. Okay, so I'll select it as Central India, and the gateway type is a VPN. I told you, right? Express route is something which I'll cover at the end of module 8. So this is not required as of now. So we will see that later. So I have told you it's a VPN tunnel, right? I told it's a VPN tunnel. So that's the reason that gateway type I have selected as a VPN. We have the different SKUs available here. So just like your storage account name and all, they have the different SKUs available. So you can study about that, the SKUs. I will post that URL in the chat. Maybe you can go there and you can study whenever you want. So just keep this link handy with you. Okay? So this is nothing but this will specify like how many, what is the bandwidth, what is the speed, how many devices and all that could be connected, etc. Okay, so as of now, like I'll select the minimum only. So VPN gateway one, I will select the minimum SKU or the specification. Okay, and it's the first generation, and yeah, and before doing that, I'll want to tell you one more thing actually. So here we select VPN itself. I have selected the generation. Let me take you to the whiteboard and I'll explain you something. One more topic I wanted to explain you in the VPN. Okay. So, like when talking about the VPN or the VPN tunnel, we have the two types of VPN. Okay. The first is the site-to-site VPN, and second one is site-to-point VPN. Remember, like the VPN tunnel which we have, there are two types of VPN. One is a site-to-site VPN. One is a point-to-site VPN. Site to. Okay. Now let us see both of this. A site-to-site VPN, which means that in Azure, if you have two sites, let us say that it was here. Okay, let us say that you have something called as one region here, which is the central India. Okay, the example which we have taken here. And let us say that you have the various the virtual machines and all, one or two virtual machines. And let us say that you have another site here or another region here, which is US. And here also you have some servers. Okay, and let us say that we have a couple of VMs, I mean, which I have already drawn right here. Let's say we have VNet and VMs which are connected to it. Okay. So let us say you have okay, instead of the US, what I'll take is that I mean, since it is for the hybrid thing, I'll explain with the hybrid. Let us say that instead of US, this is the on-premises network, okay? Because we are explaining site to site and point to site. And like even in the on-premises, you will be having the switches and a couple of machines or the virtual machines, etc. So you want to establish the connection between these two, two types, which is a private connection, right? So what is a private connection? Let us say that if you have a private IP range of maybe 10.0.0.0/16. And on premises, let us say that you have 192.168.0.0.16. Okay, why did I say private connection? Because at the end of the day, like even if we are using the public IP for the gateway, like the virtual machines, they will be having the communications via the private IP only, right? So that's the reason. So let us say that we have these two IP ranges, and if I want to enable the communication between these two, not via public IP, but via the private IP, right? I told you. So if you use the VPN tunnel here, in that case, it is known as the site-to-site VPN. So let us say that if you have the VPN gateway or the VPN tunnel connected here. So this is what we call it as a site-to-site VPN. Now, the point-to-site VPN means, now you have Azure site So let us say that the central India, this particular market like this here. Let us say that this is your the central. I mean, this is your Azure site, and let us say that you want to connect that to connectivity onto, let us say that individual machine. Maybe let us say that you have a single laptop with you, and to this laptop you want to establish a VPN tunnel. I told you, right? Like the example of in your system's laptop and all, you have the Cisco gateway connection and all. So let us say that, I mean, if you want to connect to your VPN and you have a single laptop with you, and to this laptop, you want to establish a VPN tunnel. Okay, from here, you have your virtual machine and you want to establish a connection. So this is called as the point to site VPN connection. So is the concept clear? The site to site and the point to point. So remember, site to site means that you have the Azure site and you'll be having the on-premises site. I mean, the two sites, and you will be using the VPN tunnel to establish the private communication between them. This is called as a site to site VPN. Suppose let us say that if you are an Azure site and you are having a single laptop, and if you want to establish the connection, then that is what we call it as a point to site connection. No, yeah, that is what I wanted to explain. So let me continue to the demo. So SKU, I have selected VPN gateway one. Like I told you, like it is upon the what is the bandwidth, for example, 50 Mbps and etc. So on. So that is all. It is connected in VPN gateway SKU. So you can go through that URL which I have shared. You'll be getting the more idea. Okay, and since like this is for the India, so what I'll do is that I'll select the virtual as the VNet IND. But as of now, like it is not allowing me to create use this VNet because this has been already utilized. I mean, used by my gateway. I told you right beforehand. I have created the two gateway for India and US. So just I'll tell you what exactly we are doing. So in the subnet also, like as you can see here, if I select this VNet India, that subnet which is required for the gateway subnet, it has been by default selected, which is a gateway subnet. And now the next option is that you have to create a public IP address. I told you, right? We in the previous diagram itself, I told you while explaining here, each gateway is associated with a public IP address, right? For the communication to happen. So that's the reason that like you have to create the public IP addresses. So maybe you can create a new IP, and let me see, it is EIP1. And you have to select the second public IP address as well. So this is the second public IP we are selecting. It is just for fault tolerance purpose. When I say fault tolerance, you know, right? Suppose let us say that if this particular IP address it gets deleted or something is wrong with that, what happens is that the communication is still happening. I mean, at the end of the day, the public IP to public IP communication is happening, right, between these two gateways. So if you have only one public IP and if it is deleted, then obviously the communication between them will be gone. So that is not they will not be able to communicate that. So in order for fault tolerance purposes, we have something called as the second public IP address. So once you have given that, you have to click click on next and you have to create. So by this way, and you have to do like that, and you have to create similarly, you have to create the second gateway as well, which is the gateway US. So like I told you, if creating only one gateway device, it would approximately take 20 to 25 minutes. So that's the reason that I had created it before. So any, I mean, we have one more step to perform, but before that, if you have any query, please unmute yourself and ask the query. Okay. So just let me know if you have not understood anything or if you need any, I mean, if you have any queries. So yeah. So what you have to do is that, I mean, so let me go to the US gateway right now. The left hand side in the connections, you have something called as the connections here, right? So click on add, provide the name of the connection. So it's a VNet to VN. As you can see here, we have site to site as well, right? So we'll select the VNet to VN. I will give the name as well. Maybe I'll give say US select. So I'll give US to INT. So any name you can, and the region is same by default. We had the East US region. And so these are all the different things. You can just click on review and create. Okay, so I forward to the first version that the gateway you have to select. So since I mean we are on the US, so I'll select the first gateway as US only, and the second US I'll select it as the India. Okay, so, and this key has been created by default. Maybe what I'll do is that I'll create a new one. 1, 2, 3. New add grade 23. Okay, so let me create this key. These are some keys which are required, and I'll click on review and create. And click on create. Okay, so once that is done, so let me do the similar in the second gateway as well. Um, if I'm going for the India VNet, and if I'll be going to the connections. So as you can see here, this connection is present, state is updating, and even if I go to the India as well, so this has been automatically synchronized because we have selected that configuration, right? So the currently status is updating. Once the status is online, what we can do is that, I mean, we can attach the two different VMs to that. Just like how we have performed the VNet to VN, the VNet to VNet peering. So if I take two VM, I have deleted the VM, I should not have. So if I take the two virtual machines and now if I attach one VM to the first VNet, uh, and if I attach one more VM to the second VNet, which are having the different address space and IP range, etc. And now if I try to do the ping connection, the same thing, you have to take the RDP and you have to do the ping command, and you have to put the IP address of the another virtual machine, the private IP, okay, not the public IP. So if you do that, the virtual machine is able to continue. You will get the successful ping IP, just like we have received it in the VPN to VPN field. So this is what about the VNet to VNet gateway connection, which we have. Okay, so any queries or questions you have? How really like you guys to participate it by at least giving the acknowledgement that if it is fine or not. So if the training is a two-way kind of training, so it would be good, right? Sure. And I understand that, I mean, this concept, this might look difficult at the very first stage. Today, like I'll be sharing this video as well to the new skill learning team. So once that is, I mean, you have the video created, you can check that, you can go through the video. And I would recommend that you do the demo as well. Do the demo and you will understand exactly what you have to do. Now, let me summarize in VPN to VPN gateway what we have done. So we have the two VNets, right? I have told you. So I had the two VNets, which are nothing but the VPN. Let me show you. So actually, if you have questions, you can ask. You can say there is no problem with that. So we have two VNet, as I told you, VNet India and VNet US. And if you check the address space of VNet, it is a 192.168, right? And if I check the VNet US, the address is 10.16.16. There are 2 points here. First, the address space is different. The network bit is different. There is no way that these two VNet, the two virtual machines associated to these two VNet, they can communicate, right? And the second point is that they are in different regions. So as we have studied the concept, the VMs which are in different region, they cannot communicate by default. So what we are doing is that the first, as you can see it in this diagram, we have the two VNet. So what we have to do is that if you want to utilize this gateway connection, we should have a dedicated subnet connected. So when you create the subnet, by default, usually we'll go for the default, right? You have to select it as the virtual network gateway. That's a dedicated subnet. That is a mandatory requirement. Okay. So once you have the subnet, we have to create something called as the gateway device. So that is what we have done it here. We have created the India as well as the US gateway device. And we have associated the public IP as well. You have seen that, right? So we have associated the public IP to these gateway devices. And they will, the communication between them two will be obviously, it is encrypted. The encrypted communication will happen. And the connection would be the private connection. I mean, the virtual machine, they would communicate by using the virtual IP address. So if you want to do the demo, what you can do is that create a two virtual machine. I mean, do not create the virtual network gateway first. Create the two virtual machines and associate these two virtual machines to the India subnet as well as the US subnet. And try if the ping is working. Obviously, the ping will not work, ping will fail. So once you confirm that, create the gateway devices, go to the connections, add this connection link as I have told you. So give all the required specifications. Once that is done, now try to ping. And before that, remember that you have to disable the firewall again. So firewall.cpl you have to do, and you have to disable the firewall. And if you try to do the ping right now, it should be working. So that is the reason. Okay. So as of now, the status is unknown because we do not have any virtual machines or the devices connected. So that's the reason. The encryption method, it is totally handled by the Azure itself, Amir. So you are not doing anything specifically to do the encryption. So that is totally taken care by the Azure. And as you can see here, let me show you.
One more thing. Hello?
Yeah.
One more thing. So, instead of creating the gateway, can't you create a tunnel and then we can have a tunnel?
So this method, I mean, if you might have
Tunnel.
observed that, yeah. So while creating, we have selected, there was two options for that. One was the express route and one was the VPN tunnel. So,
Okay, yes.
so that was the VPN tunnel itself. When I say the VPN, it's the VPN tunnel. And let me show you the encryption mechanism, which you asked. Amir only, right?
Yes,
also
yes.
Let me add one more connections. In the settings, you might have seen that I had given the password here, right? the PSK password, and we have IKE
Yes.
protocol. So this is the encryption method. So we just need to
Okay.
share the password, and rest everything is and we have to provide the protocol. Rest is
Right. So
managed
the
by the PC.
I key is by default the protocol for encryption.
Yeah, so it's for AES 256 and all.
Okay.
So that's different, and you can also the usually AES 256 protocol. I mean encryption mechanism, which is usually used. So you can go for either IKE v1 or IKE v2. So that is up to you. So by default, it has selected IKE. So I think this is a legacy right now, IKE v1. When I say legacy, they are going to remove that soon. So they have created the new version, and they are going with. Is that clear?
Yes.
So yeah, so that was about the connection, the details which we can, I mean, the VNet to VNet peering as well as uh, the VNet to connection devices. Now let me talk something about the DHCP. So can someone tell me what exactly do you understand when I say DHCP?
It's dynamic host configuration protocol.
Right, exactly. It's a dynamic host configuration protocol. But now first understand what exactly is a DHCP. Uh, with respect to giving and assigning the IP to a machine. Okay, so let me draw a simple diagram here. So this is my VNet. Let me say that I have three VNs. So this is the first VN, second VN, and the third VN. Okay. Now, of course, for network communication, we need IP address, so which we have discussed right now. And the DHCP is responsible for assigning IP addresses to your virtual machine. So giving IP address is a like we have two way. Either it's a manual or the static method, or it's a dynamic method. Now, what is the difference? In case of manual method, you will go to the individual machine. I mean, for that matter, I mean, even you can consider your the laptop, and therein you have to go to the network properties, and you have to provide the IP address. Let me show you from my laptop. ncpa.cpa. So as you can see here, I have the different adapters. So I'll choose the Wi-Fi adapter. I'll go to the properties. So here, as you can see here, I have the options here. This is the Internet Protocol version 50. So if I go to the properties, here, like I am obtaining the IP addresses automatically. So let us say that I have my own IP address to be specified. For example, 10.1.1.4, just for example, 10.1 in the 0.1. Just for an example, maybe you have this particular kind of. So you have to define the subnet mask as well, which we know. You have to provide the default gateway, and you have to specify your DNS server name. This is the one method of assigning the IP, which is known as the manual or the static IP assignment. On the other hand, you can enable the DHCP protocol itself, right? So as you can see here, if I go on and click on the properties, so the IP addresses are being assigned automatically. So this is happening with the help of DHCP. So if you consider your the home network setup, your DHCP is is being managed and handled by your network provider or ISPs, whether it would be Airtel, Jio, or any kind of your local the Wi-Fi brand, right? So they will be responsible for handling and configuring your DSCP. So if you have the DSCP enabled, then you will simply specify your IP range, the gateway address, the subnet mask, etc. In this case, DSCP will automatically provide IP to all your machines, right? So as you can see here, I have not specified anything. And if I open the CMD and if I do the IP config, you can see that the IP address is already assigned to my wireless LAN adapter. So that is taken care by the DSCP. So you might have noticed whenever we create a VM in Azure, all those virtual machines are getting automatically IP assignment, right? So there is not even there is not a single instance where I have manually specified the IP address for me. Like whenever we have created the virtual machines, you might have seen that we have the public IP as well as the private IP that are being automatically popping up, right? So we have not specified any IP address for that. So all those VMs are getting automatic the IP assignment via the DSCP server itself. And obviously, in our case, since it's the Azure virtual machine, the Azure will take care of this DSCP. Now, let us say I want an IP address, let us say, for example, 10.0.0.4 to be permanently stay with my VM. Then how I can configure that? For example, I don't have any VM. I have deleted that. So let us say that I have, let me create a one virtual machine very quickly. It's not demo, it's, as you can see here, I mean, I have not specified any the IP, right? So if you click on create, your virtual machine will be created and IP address will be assigned. Let us say that you will have 10.0.0.4. So what happens is that if you do the stop and deallocate method, there is a probability that this IP would change, or even for that matter, I mean, even if it is a public IP address, there is a high chances that your IP address will change. So, but I mean, that is not feasible for your application and all, right? For example, like if you have deployed your application and you have done your the domain name. I mean, when I say domain name, for example, it is google.com. It's a domain name. So you might be having like myapplication.com. So if you have that application and if you have done the mapping, we will see that DNS and all. So let us say that we have done that mapping. And by chance, if that IP address will change, so obviously your application will not work, right? I mean, if you put the DNS as myapplication.com, and let us say that the initial the mapping was for 10.0.0.4. Now, for some reason, you have stopped and deallocated your virtual machine, and that IP has been changed, whether it could be private or public IP. Now, if I try to put that URL in my browser, so what happens is that it will convert your URL, which is myapp.com, to the IP address. And since that 10.0.0.4 is gone, it will say that this web application is not available. So obviously, this will create a downtime for your customer, which is not at all recommended. So if I want to make this particular IP address, which is .04, to be permanently stay with my VM, then how can I configure that? So for that, I have to make use of something called as static IP assignment. Okay, let me show you that. Let me go to the resource. If I go to the network setting, you can see here something called as the network interface, right? So we have the network interface card or NIC or the NIC card. So now what exactly this NIC or the network interface card? It is nothing but something which allows you to get connected to your network. In my local machine, if I have the wireless adapter, which I have showed you, right? Here it is. This adapter. So I have showed you this, right? So this is the NIC actually. So the Ethernet is another NIC. You can see here that wireless Ethernet, right? Wired Ethernet. So that is also the another NIC. Now, if I go to my portal, and if you can see here, this is my network interface card, which we have it here. So this is my NIC card. So NIC is the one which enables your virtual machine to get connected to your the network. So whenever I create a VM, at least one NIC card will be present. So that is a mandatory requirement. So it is not possible that like when I create a VM, it will be created without any the network interface card, right? For example, if you remove the network the card from your laptop or the desktop, what happens is that you'll not be able to connect to the network. So you might be knowing that. So similarly for the Azure Virtual Machine, so when I create a VM, at least one NIC card will be created. More than one, it is also possible. So depending upon the user use cases, it is possible that you might be having more than one is also possible. Now, as of now, like let us concentrate on the single NIC card. Now, let me open this NIC card, which is the MyVM 8666. So here you can see here, we have the public IP address associated with that, which is 1382.10.252. And we have the private IP also, right? So that is the IP which we have created. I mean, which is assigned to your virtual machine. So with the help of this NIC card, these IPs are getting assigned to your VMs. Now, if I want to make it static, what I have to do is that in the left-hand side, you can see under the setting, we have something called this IP configuration, right? And you can see this option here, IP configure. So just click on that. Before that, let me show you something. So as you can see here, the private IP 10.104 in the bracket, it is written dynamic. It means that if I restart my VM or if I stop and deallocate my VM, there is a high probability that this the next time the IP would be like 10.1.0.5, for example. That is the meaning of dynamic IP address. So in order to make it static, I have to go to this IP config, and here you can see that option, right? Allocation. So instead of the dynamic, you have to click on static, and you have to provide what exactly IP you need. If you want to change, you can change that. In that case, let me keep the same IP address. Right? And just click on save. If I remove this, uncheck this public IP, what happens is that the VM from your VM, the public IP would be deleted. So in most of the cases, you may not require the public IP to be associated with your VM for the security purpose. So you have to go to your NIC card. You have to disassociate your public IP. So in our case, like let me associate my public IP with that and click on save. So with this method, what happens is that no, even if you try to restart your virtual machine or if you do the top and deallocation, Microsoft Azure will not change your private IP during the next reboot. Okay, so your private IP would remain same irrespective of whether it is restarted or whether it is stopped and deallocated. So this is a very important thing which you have to understand. See, as you can see here, it has been changed to the static. Now, similarly, if you want to do the public IP, what you have to do is, let me go to my VM and let me click to my the public IP. So in the configuration, you can see. Yeah, so here by default, they have the static assignment only. So that is right. So it is a static IP assignment. So this is how you can do the assignment, static IP assignment. Okay. Okay, now let us say that, like I told you, right? I mean, by any use cases I'm not. Okay, let me take an example that, I mean, when we can use more than one NIC card. So this is very, I mean, the list scenarios where you will go with that. So let us say that if you want to create a failover cluster or maybe your SQL cluster, SQL server cluster configuration on the VM, what you can do is that in that case, for heartbeat, when I say the heartbeat, it is nothing but to know the status of the VM. If the VM, when I say the status, the VM is up and running or it is down. In case of SQL configuration, in order to know the heartbeat, you can use one dedicated the NIC card. And for the data transfer, when I say the data transfer, it is nothing but your common network communication. For that, you can use a separate NIC card. So usually, we'll be having the same NIC card, but I just tell you, this is one of the use case which we might use. Okay, so if you want to do that, if I want to add one more NIC card, what I have to do is that I have to go to the overview and I have to stop my VM first. Because if the VM is running, it is not possible that you can associate, I mean, you can add another NIC card. Let us wait for that and let us wait till the VM is stopping. Okay. Okay, so the VM is in stop state right now. So you have to go to the network setting and you can see this option here, right? Attach network interface card. So as of now, you don't have anything. So just click on create a new network interface or NIC card and give the name as NIC2. Select the subnet and all. And here again, you can select dynamic or static. I'll select it as the static IP address. And let me give it 10.1.0.0. Let me give 10. 10. Okay, so and I'll click on create. So as of now, it's creating the second NIC card for me. And similarly, once the NIC card, I'll show you how to detach as well. So in interview, they might ask like, what is the steps for creating the attaching the NIC card. So you have to specify that you have to stop the virtual machine first. You have to go to the network setting and click on attach network interface, and you have to fill in the properties which you require. As you can see here, we have the two NIC card here. So one is the primary. I mean, one is the default which was selected earlier, and this is the second one. And let us say that if I do not want a NIC card, again the VM should be in stop state. Click on detach, and I'll click the one which I have created. Okay, NIC card. So by doing this, you will be able to remove the NIC card. And remember, as I told you, like there should be at least one NIC card. So you cannot delete your another default NIC card which was created. So that is what I wanted to explain in this concept. Now the next important topic which we have is called as the NSGs, or the network security group. We go to the presentation and then- So what exactly is a network security group or the NSGs? Okay, so this is what we have to understand. So is okay, now I'll explain. So NSG or the network security group, it is a security feature that acts as a virtual firewall for controlling inbound and outbound traffic to the Azure resources. So we know what exactly is a firewall. I mean, the basics one. Firewall is something which allows the incoming connections, or it will block the outgoing connections, right? So NSG is, I won't say that it is a replacement of the firewall, because Azure is having its own service called as the Azure Firewall. But for each network interface card, or the NIC or the VNet, we have the mandatory NSGs assigned to them. So they act as a virtual firewall for controlling all your incoming and outgoing traffic to your Azure resources. When I say incoming, it is nothing but, for example, let us say that in our example, this is my VM, right? Which is my VM is the virtual machine name. So incoming means maybe I have another VM, which is called as a VM India, which I had earlier. Or it might be some applications. I mean, the user might be typing the URL on the browser, and it is being redirected to the application which is hosted on this virtual machine. So these are all called as the incoming IP, incoming traffic. When I say the outgoing traffic, it is nothing but the traffic which is going from the virtual machine. For example, this virtual machine might be connected to the Azure SQL database for storing the application related data and all. So if that traffic or the connection request is going out of my virtual machine, that we usually call it as the outgoing traffic, right? So in NSG, it allows you to create the security rules that specify which traffic is allowed or denied to and from your resources within your Azure virtual network. Okay, so let me okay, we are on the network security group right now, NSGs right now. You can see the rules here, right? The first rule which you can see here, it is nothing but the RDP rule, as you can see here, right? So this is one of the RDP rule. So now I told you while creating the VM, the RDP port, which is 3389, we have enabled. Initially, this remained blocked by default, and NSGs are responsible for that. So remember that. So since while creating the virtual machine, I had selected that, okay, 3389 port should be enabled. So that is the reason that the NSGs has created a rule for you in the inbound. When I say the inbound, when I if I do the RDP, and if I try to access, sorry, if I do the RDP, and if I try to access my virtual machine, so that is what I mean, that is one of the incoming connections, right? If I take the RDP and if I put the IP address of that, and if I click on connect, so that is the incoming request for your virtual machine. While creating the machine, we have explained that, okay, the 3389 port has to be enabled. Now let us exactly see what exactly the different component of your NSG rule. Okay. So the first, you can see it is nothing but the source. The source is nothing but the origin of the traffic. So here I have selected any, right? So it means that the incoming IP, the incoming traffic, it can come from any devices. For example, if I say that, okay, my IP address, okay, and I have some CIDR ranges and all. If I define that, then okay, IP addresses. Maybe I have, if I select the option as the source as IP address, and if I put the IP address here as maybe 20.10.10.0.1, okay. So let us, if I, by chance, if I put this IP address here as the source, and if I save that, and if I try to take the RDP for that machine, what happens is that, obviously, this is not the virtual, this is not the IP address of my machine, right? So when I try to take the RDP to this particular virtual machine, if I try to take, okay, we have the virtual machine here right now, and this is my laptop, okay? So if I try to take the RDP here, what is my IP address? So if I open the CMD, and if I do the IP config, so obviously my IP address is 192.168.1.9, right? But in the source, what I've specified is that this particular IP range. So I mean to say that only the source for the incoming traffic, which is coming from only this particular IP address, that should be allowed. That is what I meant to say. And if I save that, since my IP address is 192.168.1, I will not be able to take the RDP onto this machine. Okay, you can do that by yourself once the session is completed. So for that matter, I have selected it as any. So when I select any, it will not filter anything. It will consider like any sources as the origin of the incoming resources. And here the next is the source port ranges which we are defining. For example, if I have a single port, for example, if I want that, okay, the request is coming from this particular port, I can specify that. Since this is a RDP, what I've done is that I have selected star. Destination means, again, like you have different categories here, IP address, service tax, and all. So I'll select it as any itself. So the destination is the traffic of the target of the traffic. Okay. And the destination port, we have selected it as the 3389 because we have, and you have to select the protocol. Usually you will go for the TCP, and we have the important section here, action, which is allow or deny. So what I'll do is that as of now, I'll click on deny. Okay, so by default, it is allowed now. I'll click on deny, and I'll show you the demo. And we have something called as a priority here, right? So priority here, I have given it as a 300. I'll show you what exactly is a priority error by doing the demo. So as of now, like I'll click on save. Meanwhile, let me take the public IP address copy here. So as you can see here, yeah, the security rule is already updated and the action is denied, right? So now let me take, try to take the RDP to this. For connection, I'll put the port. This is the IP address. I'll click on connect. As you can see here, it is taking a lot of time, and after some time, it will say that connection cannot be established. Okay, I'll show you that. So meanwhile, I'll explain you what exactly is a priority. As you can see here, the remote access to the server is disabled. Okay. So now what I'll do is that I'll create another rule. Inbound, we have two options, inbound and outbound. So in the inbound, I'll select the source as any, port regions again. So the destination, what I'll do is that here again, I'll select the RDP. I'll show you why. The port here, it is 3389. I'll put the allow action, and I'll put the priority as 200, and I'll explain you what exactly is this rule. What exactly is the priority. Before explaining that, let me check if the RDP works right now. I think it will not work since these are the two rules. So I'll tell you what exactly is the priority. So the priority is something like when I define the priority as 200 and priority as say 300, the rule with the priority as 200, it will take the highest precedence. So if I take this option here, 65,000, obviously 65,000 is a large number, 200 is a shorter number. So when we compare these two rules, the priority with the least value, it will take the higher precedence. So that is what the meaning. So in short, the order in which the rules are applied, it is a priority. So the numbers, the lower numbers have the higher priority. Okay? Now, if I try to take the RDP, oh, this, okay, I understood. The virtual machine itself was stop text. Okay. So that's the reason I was not able to do that. So what happens is that, I mean, the demo which I have had done was right. So let us say that, I mean, initially I had the rule as 200, which was allowing my connection, and I had the 300 priority, which was denying this, right? So you can see 200 is lesser than 300, which means that this rule would be selected and it will be processed. So that is what the importance of the inbound. When I say the outbound, it is nothing but, as you can see here, it is the outgoing traffic. Okay, so if you want, let us say that if I have a SQL database connection here, and if I want that connection to be happening, you can similarly you can create the outbound rules here, and you can do that. So this is all about the NST. So is it clear, or if you have any doubt? Okay, sure. So I have taken this session 15 minutes, 20 minutes late actually. So by 1:45 we will wrap it up. In the model 7 we have a small topic left now, which is called as the DNS. So I'll do the DNS and we will end the module 7 and today's session. Okay. So it is DNS or domain name system. So herein I'll explain you one step involved in okay, in the DNS, I'm going to explain you one of the process which is called as the name resolution. Okay, so what exactly is happening when we have a name? How the system is getting, when I say the name, I mean to say the domain name, for example, Facebook.com, and how the system is going to convert it into corresponding IP address. That's all we want to cover in this topic. Okay. So let us say that let me draw something like, let me say that you have a virtual machine, or for that matter, we can consider your laptop itself. And let me say I am trying to and then put the name as www.facebook.com. Okay. So from here on the browser, you will give a URL or address, or this is also known as the domain name, right? For example, facebook.com. So basically, like what I did is, like in the browser, I typed a domain name over there to get the corresponding website. Okay, so if I go to the browser here, I type this website. Okay, so when I typed that, what exactly happened is that like I'm typing the domain name, which is facebook.com, and over there, and trying to get the corresponding website. Now your machine will start to convert this to an IP address, right? The DNS to IP address. So what happens is that it will convert it into IP address. So we specify it as a generic IP, x.x.x.x. Maybe Facebook is associated with this particular public IP address. And your system is trying to convert that to this domain name to the IP address. And then it will be able to talk to that particular IP address, which is this IP address. This is the overall process we have. In the simple term, this is the overall process we have. So how does that takes place? First of all, in every machine, when you configure networking, in every machine there it will be configured with two DNS IP addresses, right? Like even like while explaining the VNet in Azure, I told you, right? In the available IP addresses, like the Azure reserve, I mean, apart from network ID and broadcast ID, the Azure will be reserving three IPs, one for the gateway and two for the DNS. I hope you remember. So let us say that here we have, I mean, your laptop, it is having the DNS address. That's maybe 192.168.0.1, or maybe the default name server is 8.8.8.8, the default, right? So let us say that, okay, so it could be something like your gateway only, like I told you, 192.168.0.1, or it might be some DNS server directly. You can say that. Either way, it is possible. So now you can see there is a DNS IP address associated with your machine. So now from your machine, what this machine will do is it will talk to 8.8.8.8, which is the DNS server, and ask, are you aware of what is meant by Facebook.com, for example? Okay. So it will ask like, do you have the name resolution data for Facebook.com? So when this machine requests this particular IP address about the name resolution data, this being a DNS server, this one, it's being a DNS server, it might have already found out the answer from previous user. For example, let us say that, I mean, I told you like the DNS and the DSCP, it is managed by Airtel, for example. I mean, if my ISP is Airtel, so the Airtel manages this DNS server. So now let us say that the Airtel is managing that. Maybe like my friend has already typed www.facebook.com in his browser, in his home system before me. And maybe this DNS server has already got the information that, okay, for Facebook.com IP address is say 20.1.1.1 example. Okay. So when I try to do the same thing, what happens is that I mean, it might have already found out the answer for previous user, like I told you, like my friend, right? So the DNS server is already having the answer for that, and it would have kept it in its cache. So it will respond immediately and provide the IP address to your machine. This is the one possibility, right? So your DNS server, it might already having what exactly does the www.facebook.com means. It means that it's the IP address corresponding to 20.1.1.1, for example. It might be having it this detail in its cache, and immediately, even when you type the same URL in your browser, it will immediately go and fetch this data, and it will provide to you without doing any kind of delay. Right? So this is the one possibility. Now, if at all this DNS server doesn't have the data, okay, I mean to say that, okay, let us assume that, I mean, no one knows about the Facebook.com much. Okay, so no one has searched about that in their browser, and I'm the first user who's going to the browser and typing this website. Okay, so there is a probability that this particular DNS server, which I have here, it might not be having the details related to this particular domain name resolution or the URL. It doesn't have any idea on what exactly is a Facebook.com. So what it will tell you is that go and contact something called as TLDs. Anyone knows what is the abbreviation of TLD? It's a top level domain. So the TLD. Now, one example for the TLD is your .com server. Okay, you also have something called as a .in server or .net, right? So maybe www.amazon.in. So that .in is one of the TLD server. When you type the google.com, so .com is another TLD server. So now in this image, what I'll do is that, okay, so it has, your request has come here till here. I mean, you have typed facebook.com in your browser. It has contacted your DNS, but the DNS doesn't know what exactly is facebook.com. No one has done that. So it has said that, okay, go and contact your TLD. For example, let us say that I have the .com as my TLD, okay? Because facebook.com, right? So .com is a TLD server in my case. So this .com server, which we we call it as the TLD server. And the example I have already given you, like the .net.in, .org. You might have heard that, or you might have come across that, right? So across the world, whenever a customer needs a domain, for example, I have a request for a domain name called neo.com, right? Let us say that, let us say the example of NeoSkills only. So let us say that, like I have decided that, okay, for this particular training institute, I should be having something called as neoskills.com as my website server. Okay, this should be my application. So application, everything is deployed. Maybe it could be on your app services, or it could be on your virtual machine or Kubernetes, and you decided that, okay, I should be having neoskills.com. It means that whenever I type neoskills.com, the users should be able to access my application or whatever the browser pages I have. Okay. So this domain name, you got to purchase from something called as the DNS registrar. So remember another key term. So taking neoskills.com, you cannot purchase that directly. So you have something called as DNS registrar. Okay. So example, GoDaddy. You might have heard of GoDaddy, right? So they are one of the example for DNS registers. Now the registration of your domain, that is neoskill.com, will take place on .com server placed across the world. So the step is that, let us say that, okay, if I want to purchase this neoskills.com, so what you will do is that you will contact your DNS registrar. For example, it could be the GoDaddy. You will pay them certain amount of fee, and based on the availability of this domain name, you will be able to purchase this domain. For example, if the neoskills.com is already existing and working, it's not possible that you can purchase this domain, right? So based on the availability, so what happens is that your neoskill.com registration will take place. And since it's a .com, your TLD server or the .com server, it would be having the information about the neoskills.com. Now, so the TLDs will contain the data about all the .com registration. So this is a globally true. Okay. So I mean, it could be any example. I mean, it could be google.com or facebook.com or youtube.com. So all this all are belonging to the .com TLD server. Right? So this TLD server will have all the data about these domains. For example, if it is amazon.in, so in is your TLD server. So in registration will be taking place in the in TLD server. The details like the who has registered that, then whom to contact, etc. Everything will be written. I mean, all that data will be available in your TLD server. So now you can see we actually bought neoskill.com from GoDaddy, right? So GoDaddy has become the DNS registrar who registered this particular domain name under the .com TLD server. So did we go to .com TLD? Okay, so now your .com TLD. So let me take the example of instead of the Facebook.com, let me take this example, www.neoskills.com. Okay. Now, when I typed this neoskill.com in my browser, the request will go to the .com TLD server, and it will respond to you with, okay, so data about this is available from your DNS registrar, which is nothing but your GoDaddy. So go and contact your GoDaddy servers. We have it here. So the neoskill.com, initially it came to your DNS server. The DNS server didn't have any idea that what exactly is the neoskills.com. So what it has done is that it has contacted your .com TLD server. And just to give the background, I have told you that we have purchased this domain from GoDaddy.com. Okay, so it will go to the GoDaddy. So when the request comes to the .com TLD server, it will tell you that okay, the DNS registrar for this particular domain is the GoDaddy. So go and contact them. So what happens is that your request will come here. So and it will tell that DNS registrars. Like this. I'll tell you. So it will point you to DNS registrar, it's a server, DNS server, and give the particular and ask you to talk to that particular server. Okay. So what exactly happened was TLD gave you a DNS server address on which the registration would have happened from GoDaddy. So the next step is that you will talk to GoDaddy DNS server. So the DNS, the GoDaddy, obviously they will be having their own DNS servers. So the .com has, informed you that, okay, the information about this particular domain, it is present in your DNS registrar DNS name server or the domain server. So go and talk to their DNS server, and you will, and it will ask what exactly is in your neoskill.com. Now on this GoDaddy server, you will have something called as a zone file. Okay. So we have reached till here. So they will be having their own DNS server. The GoDaddy.com. So each of these server will be having something called as a zone file. This zone file will contain all the records. That is, for example, the DNS. That is for the DNS, whatever the records are necessary, all that records will be available within inside that zone file. I'll explain you what exactly the data are available. Okay. Now in this file, it will fetch something called as we have something called as a record. So type it here. One of the details or one of the record which we have is called as the a record, and it will have a corresponding IP address for that. For example, for our neoskills.com, the corresponding IP address is 20.10.1.0. Okay. So this is the IP address, what exactly your browser was looking for. So let me explain you again. So you typed www.neoskill.com, but before that, like we have purchased the neoskills.com from DNS registrar, which is the GoDaddy. So your local DNS server, it doesn't have any idea what exactly the neoskill.com is. So what it will do is that it will fetch the last part, which is .com, and it will redirect your request to .com TLD server or the top level domain server. Now the .com server will be having the details about all the .com registrations. So it will come to know that, okay, who is the DNS registrar for this particular domain name. So it will ask the browser to go and check, or your machine to go and check for the details in GoDaddy in the GoDaddy or the DNS registrar's DNS server address in the DNS server. So they will be having their own DNS servers, and in each DNS server they will be having something called as the zone file. Inside the zone file, you will be having different records. What we are interested here is that it is called as the A record. So in the A record, you will be find what is the corresponding IP address for the neoskill.com. So finally, your machine has got the IP address which was needed, and it will take you to the application homepage. So remember that this will happen before, even before you can notice that. Within a blink of the eye, this will happen. Okay, so this will not take the delays on it. So this will happen very fast. So there are different records available. This is just for your understanding. I'm telling you. We have different records in the zone file or the DNS server. I told you, right? In DNS server, we have something called as a zone file. So in the zone file, we have something called as a record. It will have your domain IP. For example, 20.1.1.1. You have 4 times a record. This is for your IPv6 IP addresses. We have something called as the MX record. MX report, it is for mail server data. Suppose let us say that if you have your own mail server, and if you want to maintain that data and all, its IP address will be here. We have the text TXT record, the text record. It is used for verification purposes and all. Okay, and we have the PTR or the pointer record. It is used with Active Directory to point your SOA and all. SOA means I mean to say the start of authority. And we have something called as a CNAME record as well. For example, the alias of your application. For example, neoskills.com can also be referred as neo.com. So these are the two different domain names. So if I put either of these name, I should be having the corresponding, I mean, just putting the alias, I can say, or having the different or adding the different domain name for one particular IP address. So you can do it in CNAME as well. So that is what in generic we have in the DNS. Now let me explain you, and I'll take 5 more minutes. So let me explain you what exactly happens when we have something called as the Azure DNS server. In Azure also, we have something called as the DNS. In Azure DNS, what happens is that I'll tell you. Now the zone file, okay. I told you, right, this zone file, which contains the various record, you can offload it onto the Azure. When I say the offload, it means that I can remove it from GoDaddy's registration, and I mean GoDaddy's DNS server, and I can put it in the Azure DNS server itself, which means that now here on, okay, it means that so here there will be slight changes right now, right? So your DNS registrar will receive the request. I mean, the flow would be same. It will come till the DNS registrar DNS server address. And it will see, and your DNS server or the GoDaddy, it will see that, okay, you have offloaded your request onto the Azure, which means the DNS, because now this server has your zone file. So what happens is that instead of going to the GoDaddy's DNS server, it will route this server to something called as the Azure DNS. So we'll do a small demo also, I'll show you that. So now your zone file would be present here. So that is what a slight changes will happen. So the change is that instead of using the GoDaddy's DNS server, we'll be having our Azure's own DNS server. So there are the many advantages of that. The first is that, I mean, if you do not want to maintain your, see, like you might be having your payment related application and all, right? So it is not recommended that, I mean, you may not feel secure that, okay, I will go to the GoDaddy's DNS server and I'll do the registration. So for that reason, you might want to maintain your separate DNS server, and Azure will provide you the service. And if you use the Azure DNS server, it will use the Azure's the backbone infrastructure, I mean the network infrastructure, and the performance will be high, the latency will be less. So that's the reason that we have that. Okay, so I'll do a small demo, then we can wrap up the session. So in the portal, just select the DNS zones. Just click on create. The subscription you can put is a demo actually. You can give the name. Okay, so for example, my application was neoskills.com. Okay. I mean, as of now, I mean, I have not purchased this domain. Nothing is existing. Just for your reference, I'm doing that. Okay. So let us say that I told you, right? You can offload your zone file. So if that is the thing, you can, I mean, upload that file. Maybe you have downloaded the file from the GoDaddy registration, GoDaddy site, and you can upload that file. As of now, I do not have anything. I'll just click on create. Click on create. So till the creation, okay. So now, first of all, you want to redirect the request onto this zone file, no, right? Let me wait for. If I have already one created. Okay, so let us say that this is the one which I have created. So these are the record sets. So these are the different records which are getting connected. I told you about SOA, right? Pointer record. So these are the different records. If I go to the overview, you can see here the name servers, different name servers. So these are the name servers which are being managed by Azure, and they are dedicated for you. So now, first of all, you want to redirect the request. When we say the request, it is neoskills.com to this particular zone file. So far, this zone file, also there are a couple of name servers, right? So NS1 36, NS2 36, etc. So these are all the name servers which are responsible for this zone files, which are created in Azure. Now, our request, when someone types neoskills.com on their browser, that request will eventually come here. So I told you, right? So instead of going here, our request, because we have already offloaded the zone file, so it will come here, and you should be able to, it should be able to provide the particular IP address. So I do not have the GoDaddy account. I think Akhil or someone already have the GoDaddy. So I'll let me check if I have some images. And, so how you can change is that in the GoDaddy registration, in the GoDaddy, in the manage, there is a section called as a manage domain, and if you scroll down, they have their okay. Okay, so this is a typical GoDaddy's name server. I hope you can see that. Right, so this is if you scroll down in your GoDaddy account, you can see the different name server. It's the default name server. So what you have to do is you have to delete these name servers, and you have to copy all the 4 name servers, and you have to add it here. So this is how you are instructing that when the request is coming here. So it is not going to the GoDaddy server. As you can see here in the browser, it is mentioned ns1.godaddy.com, right? But in our Azure, we have mentioned ns136 azure-dns.com. So what happens is that this request is automatically being carried out to your DNS server zone. Now, let us say that in the GoDaddy page, you might be having the records like this, okay? So these are the different records. For example, we have the A record where he is mapping your IP address to the particular domain. So that domain name is not visible here. So usually that domain name will be present here. For example, neoskill.com. So once you have offloaded this zone file into your DNS server, you can go ahead and you can delete that, okay? Because whatever the request is coming, it will not go to this particular zone file. Rather, it will go to your DNS Azure DNS server, and you can maintain all your files, record files here. If you have, if you want to upload, I don't have anything, I told you, right? So if you want, you can add any records also here, or if you have the file, you can directly upload here, and you can get the result. So that is what about the DNS, and the last part is that we have the 2 DNS here. So what I have explained you till now, it is a public DNS. Okay, and apart from this, Azure is also providing something called as the private IP, the private DNS. Okay, so what I have explained you, it is a public one, right? Because like the neoskill.com, you are browsing that over the internet, and you are getting the access. Now, what exactly is a private DNS? Private DNS is something which we use inside the local network or the LAN. So let us say that within our company, we will be obviously having our own different application. For example, ServiceNow portal. You might have heard that, right? You do not want your company ServiceNow portal to be available over the internet. So that's the reason that so that's the reason that yes, I think. So that's the reason that I mean, what we use is we use something called as the private DNS address. So if I draw a small diagram here, so I have the VNet here. You have the different virtual machine. Maybe this is 10.0.0.4. This is 0.5. This is 0.6, and this is 0.7. Okay, so now let us say that you have some web app or anything hosted on this virtual machine, and you need to access the machine via the browser. Okay, so if you type, I mean, if you let us say that your service now is placed on the server, which is having IP address, say like 172.10.4.5:8080, just for example. So that is not easy to remember, right? So what is easy to remember is that the name which are easy to remember. For example, if I have the address like snowflake.neo.com. So this is easy to remember rather than 172.12.15.67, then maybe colon 3, 4, 4, 6, so something like that. So this is not looking professional, and this is not easy to remember, right? Service no, not this Snowflake. So just an example. So in that case, what we need to do is that we need to have something called as the private DNS for our environment. So the operation, I mean, the mechanism would be same. So instead of going over to the internet, so what happens is that they will use this private DNS, and all this virtual machine, they would be able to communicate internally. So this is not going to the external side. So they'll make use of the private DNS here, the Azure private DNS here. All the communication will happen in this fashion. So there is one small topic about the private DNS. So with this, the DNS topic as well as the module 7 is completed. Okay, so from tomorrow, like I'll be covering the advanced VNet concept, which is a load balancing solution. So any doubts or queries on this, or we are good to close? Yeah, any queries, or we are good to go? Can you please confirm in the chat? Okay, sure. So with this, we will finish our session. So see you tomorrow. Have a nice day. Bye bye.